Welcome, and prepare yourself for a journey into the remarkable world of squirrels. These bushy-tailed creatures have captivated humans for centuries, and tonight, we'll explore every fascinating detail of their lives. Let's begin with a simple truth. Squirrels belong to the family Sciuridae, a name derived from the Greek words skia, meaning shadow, and aura, meaning tail. The ancient Greeks noticed how squirrels would sit with their magnificent tails curved over their backs, creating their own shade, and thus these creatures became known as shadowtails. There are over 200 species of squirrels living across the world. From the tiny African pygmy squirrel, which weighs barely more than a few coins, to the massive Indian giant squirrel that can grow 3 feet long, these animals have adapted to nearly every habitat where trees grow. You'll find them in forests, parks, cities, and mountains, from sea level to elevations over 14,000 feet. Squirrels are generally divided into 3 main types. Tree squirrels are the ones most of us know, living in and around trees with their characteristic bushy tails. Ground squirrels, which include prairie dogs and chipmunks, make their homes in burrows beneath the earth. And then there are flying squirrels, which don't actually fly but glide through the air using special membranes stretched between their limbs. The common gray squirrel, found throughout North America and introduced to parts of Europe, typically lives between 6 and 12 years in the wild. In captivity, where they're protected from predators and have consistent food, some have lived over 20 years. Every day of those years is filled with activity, planning, and survival. A squirrel's tail is not just for show. This magnificent plume serves as a blanket in winter, keeping them warm during the coldest nights. In summer, it becomes a parasol, shading them from the intense sun. When a squirrel leaps through the trees, the tail acts as a rudder, helping them steer through the air and maintain balance. And when confronted by a predator, a squirrel will often flick its tail in specific patterns to communicate danger to other squirrels nearby. These creatures have teeth that never stop growing throughout their entire lives. A squirrel's 4 front teeth, 2 on top and 2 on bottom, grow about 6 inches per year. To keep them from growing too long, squirrels must constantly gnaw on hard materials like nuts, bark, and twigs. This gnawing wears down their teeth at just the right rate to keep them sharp and the perfect length for cracking open the toughest shells. Squirrels can rotate their hind feet 180 degrees, allowing them to descend trees headfirst. Watch a squirrel carefully as it comes down a tree trunk, and you'll notice its back feet have turned completely backward, gripping the bark with their sharp claws. This remarkable adaptation makes them one of the few mammals capable of this feat. The eating habits of squirrels are more sophisticated than you might imagine. A single gray squirrel can bury thousands of nuts and seeds in a season, creating hundreds of different cache sites spread across several acres. What's truly remarkable is their memory and sense of smell allow them to relocate about 80% of these buried treasures, even under a foot of snow. The squirrel's daily life. As dawn breaks, a squirrel's day begins. These creatures are primarily crepuscular, meaning they're most active during the twilight hours of early morning and late evening. During these times, the light is perfect for their vision, and many of their predators are less active. A squirrel spends nearly 80% of its waking hours searching for food, eating, or storing food for later. This constant preoccupation with nutrition isn't laziness or gluttony, it's survival. Squirrels have extremely high metabolisms and must eat roughly their body weight in food each week just to maintain their energy levels. The diet of a squirrel is more varied than most people realize. While they're famous for eating nuts and acorns, squirrels are actually omnivores. They feast on fungi, tree bark, bird eggs, insects, and even small snakes when the opportunity presents itself. In spring, they'll eat tender buds and flowers. In summer, fruits and berries become staples. By fall, they shift their focus to nuts and seeds, which they'll cache for winter. When a squirrel eats a nut, it doesn't just crack it open randomly. Research has shown that squirrels evaluate each nut by weighing it in their paws and even shaking it near their ears. If a nut is bad or hollow, they can tell before investing the energy to crack it open. This assessment takes only a second or two but saves them enormous effort over the course of a season. Squirrels build elaborate nests called drays, usually high in the branches of trees. A dray looks like a messy ball of leaves and twigs from the outside, but inside it's remarkably sophisticated. The outer layer is made of woven twigs to provide structure. The middle layer consists of moss and damp leaves compressed together for insulation. The innermost chamber is lined with soft materials like grass, shredded bark, and sometimes even fur or feathers. Most squirrels will maintain several drays within their territory. One serves as their main residence, while others act as backup homes if the primary nest is disturbed by predators or storms. Some drays are used specifically for raising young, while others are simply for sleeping and shelter. The social structure of squirrel communities is more complex than it appears. While squirrels don't form tight packs like wolves, they do establish hierarchies based on age, size, and dominance. Older, larger squirrels typically have access to the best feeding areas and nesting sites. However, during mating season, these hierarchies can shift as males compete aggressively for the attention of females. Communication among squirrels happens through multiple channels simultaneously. They use at least 8 different vocalizations, from high-pitched alarm calls to softer purring sounds when content. Their tails convey information through specific flicking patterns. They also communicate through scent, leaving pheromone markers on trees and at cache sites to indicate territory or to help them relocate buried food. When a squirrel detects a predator, it doesn't just flee. Instead, it often performs what's called a seat call or a kook call depending on the type of threat. A seat is a high-pitched whistle used when aerial predators like hawks are near. A kook is a staccato chattering sound indicating a ground predator like a fox or cat. Other squirrels in the area immediately recognize these calls and respond accordingly. Squirrel superpowers. The physical abilities of squirrels border on the superhuman, at least when scaled to their size. A squirrel can jump 10 times its body length horizontally and can leap up to 20 feet from tree to tree. When you consider that most squirrels are only about 10 inches long, this means they're jumping 10 to 20 times their own length through the air with precision and grace. These acrobatic feats are possible because of the squirrel's unique skeletal structure. Their bones are lightweight but incredibly strong, and their bodies are primarily composed of lean muscle. When a squirrel prepares to jump, it can calculate distance, wind speed, and landing spot in mere fractions of a second. Scientists believe they use a combination of visual cues and memory of previous jumps to make these split-second calculations. A squirrel's eyes are positioned on the sides of its head, giving it an almost 360-degree field of vision. This allows them to watch for predators in nearly every direction without moving their heads. However, they do have a small blind spot directly behind them and immediately in front of their nose. To compensate, squirrels are constantly moving their heads in small, quick motions to fill in these visual gaps. Their eyes see the world differently than ours. While squirrels have color vision, they see yellows and greens particularly well, which helps them identify ripe fruits and healthy vegetation. Their vision is optimized for detecting motion, making them incredibly sensitive to any movement in their environment, whether it's a falling leaf or an approaching hawk. The sense of smell in squirrels is extraordinarily acute. They can detect nuts buried under a foot of snow, and they use smell to determine which nuts are good and which have gone rotten without having to dig them up. Scientists have discovered that squirrels can smell through multiple layers of packaging, which is why they can be such persistent raiders of bird feeders and garbage cans. Touch is another critical sense for squirrels. They have whiskers not just on their faces but also on their wrists and ankles. These whiskers, called vibrissae, detect air currents and help squirrels navigate through dense branches in complete darkness. When a squirrel runs along a branch at night, these whiskers are constantly providing information about the space around them. Squirrels have excellent hearing, capable of detecting sounds well into the ultrasonic range. They can hear the high-frequency sounds made by other small animals, the wings of approaching hawks, and even the subtle scratching of insects beneath tree bark. This acute hearing helps them locate food and avoid danger simultaneously. The metabolism of a squirrel is remarkably efficient. During summer, when food is abundant, squirrels will eat extra and build up fat reserves. As winter approaches, their bodies undergo metabolic changes that allow them to survive on less food. While they don't hibernate like bears, they do enter periods of reduced activity during extreme cold, living off their stored body fat and cached food. Temperature regulation in squirrels is a marvel of biology. In winter, they can reduce blood flow to their extremities to conserve heat in their core. Their fur becomes thicker, trapping air for insulation. In summer, they can increase blood flow to their ears and tail, using them as radiators to cool down. You might see a squirrel spread out flat on a cool surface in summer, maximizing skin contact to shed excess heat. The changing seasons. For a squirrel, autumn is the most critical season of the year. As days shorten and temperatures drop, squirrels enter a state of hyperphagia, which means excessive eating. During this period, a squirrel might spend up to 18 hours a day foraging and caching food. They can gain up to 50% more body weight in preparation for winter's scarcity. The caching behavior of squirrels during autumn is extraordinarily sophisticated. They don't just bury nuts randomly. Instead, they engage in what scientists call scatter hoarding, creating many small caches rather than one large storage site. This strategy protects them from total loss if one cache is discovered by another animal. Research has shown that squirrels often create fake caches, pretending to bury a nut while actually keeping it in their mouth, possibly to confuse potential thieves watching them. Squirrels also practice what's known as spatial chunking. They organize their caches by nut type, creating areas where they store primarily acorns, other areas for hickory nuts, and so on. This organization isn't random, they actually remember these locations and the contents, making retrieval more efficient when they need specific nutrients. Winter brings new challenges. When snow covers the ground, squirrels rely on their incredible sense of smell to locate buried nuts. They can detect a nut through 12 inches of snow. But winter is also when their social behaviors shift. Squirrels that are normally territorial might share a dray with others during the coldest nights, huddling together for warmth. These groups can include up to 8 squirrels, though 4 is more common. On particularly cold winter days, squirrels might not emerge from their drays at all. Instead, they enter a state of reduced activity, lowering their body temperature slightly and moving as little as possible to conserve energy. This isn't true hibernation, they can wake quickly if needed, but it serves a similar purpose of energy conservation. Spring arrives with an explosion of activity. This is mating season for most squirrel species, and the normally individualistic animals become intensely focused on reproduction. Male squirrels will chase females through the trees in elaborate courtship pursuits that can last for hours. Multiple males might compete for a single female, leading to aerial acrobatics and chattering confrontations. The mating chase serves several purposes. It allows the female to assess the fitness of potential mates, as only the strongest and most agile males can keep up. It also synchronizes the female's reproductive system, preparing her body for pregnancy. After mating, the female drives away all males and prepares a special maternal dray for her coming litter. Pregnancy in squirrels lasts about 44 days. During this time, the mother squirrel becomes exceptionally efficient at foraging, as she needs to eat significantly more to support the developing babies. She also spends considerable time improving her maternal dray, making it softer and more secure than her regular sleeping nests. Summer brings the sight of young squirrels taking their first ventures outside the nest. Baby squirrels, called kits or kittens, are born blind, deaf, and completely helpless. They're pink, hairless, and weigh less than an ounce. For the first 7 weeks of life, they depend entirely on their mother's milk and warmth. Growing up squirrel. At around 8 weeks old, young squirrels finally open their eyes and begin to explore their immediate surroundings within the dray. Their first glimpses of the world reveal the interior of their leafy home, their siblings squirming beside them, and occasionally their mother returning with food. This period of early exploration is cautious and brief, as the babies still lack coordination. By 10 weeks, the young squirrels venture out onto the branches near their nest for the first time. These initial expeditions are clumsy and dangerous. Baby squirrels have not yet developed the incredible balance and judgment their parents possess. Falls are common, and this is one of the most dangerous periods in a squirrel's life. However, their lightweight and flexible bones mean many falls that would be fatal to other animals result in only minor injuries for young squirrels. The mother squirrel teaches her young through a combination of demonstration and allowing them to practice. She shows them how to crack open nuts, where to find food, how to build caches, and which trees are safe for quick escapes. Young squirrels are natural mimics, watching their mother intently and copying her behaviors. This learning period lasts about 3 months. During their education, young squirrels develop their jumping abilities gradually. At first, they can only manage short hops between nearby branches. But each day, their confidence and skill grow. They practice jumping repeatedly, learning to judge distances and account for wind and branch flexibility. By 12 weeks old, they can make jumps that would have terrified them just weeks earlier. Play is a crucial part of squirrel development. Young squirrels engage in what appears to be wrestling, chasing, and mock battles with their siblings. These games serve serious purposes, developing the physical skills and quick reflexes they'll need to escape predators, establishing social hierarchies, and practicing the acrobatic maneuvers essential for life in the trees. At around 12 weeks old, squirrels are weaned from their mother's milk and must find all their own food. This transition is gradual, with the mother squirrel bringing them less and less food over the course of several weeks. By the time weaning is complete, the young squirrels have already learned where to forage and what to eat through their weeks of observation. By 4 months old, young squirrels are nearly independent. The mother squirrel begins to chase them away from her territory, forcing them to establish their own home ranges. This dispersal is essential for preventing inbreeding and ensuring genetic diversity in the squirrel population. Young males typically disperse farther than females, sometimes traveling several miles to find unclaimed territory. Finding territory is one of the greatest challenges young squirrels face. All the best habitat is usually already claimed by established adults. Young squirrels must either find marginal territories between established ranges or wait for an adult squirrel to die or move, opening up prime real estate. Many young squirrels don't survive their first winter, as they're forced into poor territories with insufficient food or inadequate shelter. Those that do survive their first year have learned the essential skills of squirrel life. They know their territory intimately, every tree, every good foraging spot, every safe retreat from predators. They've experienced a full seasonal cycle and understand how to prepare for winter. They're now ready to compete for mates and start the cycle anew with their own offspring. Squirrel intelligence. The intelligence of squirrels has been seriously underestimated for most of human history. Modern research reveals these small mammals possess problem-solving abilities that rival some primates. In laboratory tests, squirrels have demonstrated the ability to learn complex sequences, remember solutions to puzzles for up to 2 years, and even adapt their strategies when faced with new variations of familiar problems. One remarkable study tested squirrels' ability to navigate increasingly complex mazes to reach food rewards. The researchers expected the squirrels to solve the mazes through trial and error. Instead, the squirrels would often pause at decision points, appearing to think through options before choosing a path. Even more impressive, once they learned a maze, they remembered the solution for months without any practice in between. Squirrels also demonstrate what scientists call deceptive caching. When a squirrel knows it's being watched by potential thieves, either other squirrels or birds, it will alter its caching behavior. It might pretend to bury nuts in multiple locations while actually keeping them in its mouth, or it might create more fake caches than usual. After the observer leaves, the squirrel returns and actually buries the nuts in different locations. This suggests squirrels understand that other animals have knowledge and intentions separate from their own, a concept called theory of mind. The learning ability of squirrels extends to urban environments. City squirrels have learned that humans represent both danger and opportunity. They've adapted to cross streets by waiting for breaks in traffic and even using crosswalks in some cities. They've learned which humans feed them and which might pose threats. Some urban squirrels have even learned to open complex latches and locks to access bird feeders, with new techniques spreading through populations as squirrels observe and copy each other. Memory is perhaps the most studied aspect of squirrel cognition. As mentioned earlier, squirrels can remember the locations of thousands of cached nuts. But they don't just remember locations, they remember what they buried where. Studies using GPS trackers and marked nuts revealed that squirrels selectively retrieve certain nuts based on their nutritional needs. If a squirrel needs quick energy, it retrieves high-carbohydrate acorns. If it needs sustained energy, it goes for high-fat walnuts or hickory nuts. Spatial memory in squirrels relies on multiple cues. They use landmarks like large trees, rocks, and even human-made structures. They also use geometric relationships between objects, creating mental maps of their territories. Scientists have tested this by moving landmarks after squirrels cached nuts nearby. The squirrels searched in locations that maintained the geometric relationship to other landmarks, showing they weren't just memorizing isolated locations but understanding spatial relationships. Squirrels can also count, at least up to small numbers. In experiments where squirrels watched nuts being placed into opaque containers, they would search longer if fewer nuts were available than they had seen being hidden. This suggests they maintain a mental representation of quantities and have expectations based on these representations. Tool use in squirrels is rare but documented. Some squirrels have been observed using sticks to manipulate objects they can't reach with their paws or to extract insects from bark crevices. While not as sophisticated as the tool use seen in crows or chimpanzees, it demonstrates behavioral flexibility and problem-solving ability. The ability of squirrels to assess risk is remarkably nuanced. They don't just flee from all potential threats. Instead, they evaluate multiple factors: the type of predator, its distance, its behavior, available escape routes, and even how hungry they are. A squirrel that's well-fed is more cautious than one that's desperate for food. This cost-benefit analysis happens in seconds and shows sophisticated decision-making abilities. Predators and survival. In the wild, squirrels face danger from above, below, and all around. Their lives are a constant dance with death, and only the most alert, quick, and clever individuals survive to old age. The list of animals that prey on squirrels is long and varied, changing depending on geography and habitat. From the sky, hawks and owls pose perhaps the greatest threat. Red-tailed hawks are particularly efficient squirrel predators, using their keen eyesight to spot movement from hundreds of feet away. They dive at speeds over 120 miles per hour, giving squirrels only seconds to react. Owls hunt at night, when some squirrel species are active at dusk or dawn, using silent flight to approach undetected. On the ground, the threats multiply. Foxes, coyotes, and bobcats all hunt squirrels. Domestic cats are also significant predators, especially of young or injured squirrels. Snakes, particularly rat snakes and bull snakes, will climb trees to raid nests and eat baby squirrels. Even weasels, despite being smaller than adult squirrels, are fierce predators capable of killing and eating squirrels. The anti-predator behaviors of squirrels are diverse and sophisticated. When a squirrel spots a hawk, it doesn't just hide, it freezes in place and watches the predator. Squirrels have learned that hawks hunt primarily by detecting movement. A motionless squirrel pressed against a tree trunk is nearly invisible from above. The squirrel will maintain this frozen position for several minutes if necessary, watching the hawk until it's certain the danger has passed. For ground predators, the strategy is different. Squirrels rely on their superior climbing ability and agility. When pursued by a fox or cat, a squirrel will spiral around a tree trunk, keeping the trunk between itself and the predator. It moves in quick, unpredictable bursts, making it difficult for the predator to anticipate its next position. If necessary, the squirrel will leap to another tree, something most ground predators can't follow. The alarm calls that squirrels make when they spot predators serve multiple purposes. Obviously, they warn other squirrels. But research has shown these calls also serve to inform the predator that it's been spotted. Many predators rely on surprise, and once they know their cover is blown, they often give up the hunt. By calling, a squirrel might actually reduce its risk by removing the element of surprise. Squirrels also practice what's called predator inspection. Rather than immediately fleeing from a potential threat, a squirrel might actually approach it cautiously to gather more information. Is it really a threat? Is it actively hunting? This risky behavior provides valuable information that helps the squirrel decide whether to abandon its current activity or whether it can continue foraging while remaining vigilant. The relationship between squirrels and their predators creates what ecologists call a landscape of fear. Certain areas within a squirrel's territory are more dangerous than others, perhaps because they're more open or closer to where predators are common. Squirrels adjust their behavior based on where they are in this landscape, being more cautious in dangerous zones and more relaxed in safer areas. Survival for a squirrel means being perpetually aware. They're constantly scanning their environment, listening for unusual sounds, and monitoring the behavior of other animals. This vigilance comes at a cost. Squirrels must balance the time spent watching for danger with the time needed to forage for food. This is why squirrels often forage in short bursts, eating quickly and then pausing to scan for threats. Ground squirrels and their underground cities. While tree squirrels live in the branches and flying squirrels glide through the air, ground squirrels have mastered life beneath the earth. These animals create extensive burrow systems that can stretch for dozens of feet underground, complete with multiple chambers, escape tunnels, and even toilet areas separate from their living spaces. Prairie dogs are perhaps the most famous ground squirrels, known for their elaborate underground towns that can cover hundreds of acres and house thousands of individuals. These burrow systems are marvels of engineering, with different tunnels serving different purposes. Some tunnels lead to deep chambers where prairie dogs sleep, safe from temperature extremes. Other tunnels have listening posts near the surface where sentries can watch for predators. Still others are escape routes with multiple exits. The ventilation system in prairie dog burrows demonstrates remarkable sophistication. The entrances are built at different heights, creating a pressure differential that draws fresh air through the tunnels. One entrance might be built up into a mound, while another is left at ground level. This difference in height creates airflow similar to a chimney, constantly refreshing the air in the deep chambers where prairie dogs spend much of their time. Ground squirrels include many species beyond prairie dogs. The 13-lined ground squirrel of North American grasslands gets its name from the striking stripes and spots running down its back. The California ground squirrel is a common sight throughout the western United States. The Arctic ground squirrel survives in the harsh tundra of Alaska and northern Canada, hibernating for up to 8 months each year in underground burrows insulated by permafrost. Unlike tree squirrels, many ground squirrels are true hibernators. As winter approaches, they retreat to their deepest chambers and enter a state called torpor. Their body temperature drops dramatically, sometimes to just a few degrees above freezing. Their heart rate slows from over 200 beats per minute to fewer than 10. Their breathing becomes so slow that they might take only one breath every few minutes. In this state, they can survive for months without eating or drinking. The hibernation of Arctic ground squirrels is the most extreme of any mammal. Their body temperature can drop below freezing to as low as 26 degrees Fahrenheit, yet they don't freeze solid. This supercooling is possible because they've eliminated all the ice nucleating particles from their tissues that would normally trigger freezing. Every few weeks during hibernation, they briefly rewarm their bodies for about 12 hours before dropping back into torpor, though scientists still aren't certain why this periodic rewarming is necessary. Ground squirrels face different predators than tree squirrels. Badgers are specialized ground squirrel predators, using their powerful claws to dig into burrows. Snakes can follow ground squirrels into their tunnels, making underground retreats not always safe. Coyotes, foxes, and birds of prey all hunt ground squirrels. Some ground squirrel species have evolved specific defenses against particular predators. California ground squirrels, for example, have developed resistance to rattlesnake venom and will actually confront and harass rattlesnakes to drive them away from their burrows. The social structure of ground squirrel colonies varies by species. Prairie dogs have complex social groups called coteries, usually consisting of one adult male, several adult females, and their young. These groups defend territories within the larger colony and cooperate in watching for predators. When danger is spotted, prairie dogs give specific alarm calls that indicate what type of predator is approaching and how urgent the threat is. Communication in prairie dog colonies is extraordinarily sophisticated. Research has revealed that prairie dog alarm calls contain detailed information about predators, including their species, size, color, and even the speed and direction of approach. Prairie dogs have different calls for humans, dogs, coyotes, and hawks. They can even incorporate information about specific individual humans they've seen before, suggesting their communication system has a rudimentary grammar and syntax. Squirrels around the world. The diversity of squirrel species across the globe is astounding. On every continent except Australia and Antarctica, Squirrels have evolved to fill ecological niches and exploit available food sources. Each species tells a story of adaptation to local conditions, climate, and competition. In the tropical rainforests of Southeast Asia lives the giant squirrel, a creature that can weigh up to 7 pounds and reach 3 feet in length. These magnificent animals have strikingly colored fur, often in combinations of black, brown, white, and maroon. They spend their entire lives high in the rainforest canopy, rarely descending to the ground. Their diet consists mainly of fruits, nuts, bark, and insects found among the towering trees. The African pygmy squirrel, in contrast, is one of the smallest squirrels in the world. Adults weigh less than half an ounce, about the weight of 3 pennies. These tiny creatures live in the rainforests of West Africa, where they forage for insects and tree sap. Despite their small size, they're aggressive in defending their territories from other pygmy squirrels and can be heard making surprisingly loud calls for such diminutive animals. European red squirrels have become a symbol of conservation efforts in the United Kingdom and Ireland. These beautiful animals, with their russet fur and distinctive ear tufts, once thrived throughout Britain. However, the introduction of the larger American gray squirrel in the 1800s has led to dramatic declines in red squirrel populations. Gray squirrels outcompete red squirrels for food, can survive in more varied habitats, and carry a disease called squirrelpox that is deadly to red squirrels but doesn't affect gray squirrels. The Indian palm squirrel is one of the most common mammals in urban India. These small, striped squirrels have adapted remarkably well to city life, living in parks, gardens, and even inside buildings. In Hindu tradition, these squirrels are considered sacred, and there's a legend that the stripes on their backs were created by the god Rama's fingers when he blessed a squirrel that helped build a bridge by carrying small stones. In the high mountains of the Himalayas lives the Himalayan striped squirrel, an animal adapted to life at elevations where the air is thin and temperatures are extreme. These squirrels have larger lungs than their lowland relatives, allowing them to extract more oxygen from the thin mountain air. Their fur is thicker and grows in multiple layers for insulation against the bitter cold. The Japanese squirrel, native to Japan, is another species with prominent ear tufts that change with the seasons. In winter, their ear tufts grow long and fluffy, while in summer they shrink or disappear entirely. These squirrels live in both deciduous and coniferous forests and have adapted to the heavy snowfall that occurs in many parts of Japan by caching food in multiple locations and remembering where they've stored it beneath the snow. African ground squirrels have evolved a remarkable behavior to cope with the intense heat of the African savanna. They use their large, bushy tails as parasols, holding them up over their backs to create shade. The tail's hairs are arranged in a way that reflects sunlight while allowing air to circulate, keeping the squirrel's body temperature down. This behavior, called heat shielding, can reduce the temperature of their bodies by several degrees. The Mentawai squirrel, found only on the Mentawai Islands off the coast of Sumatra, is one of the world's rarest squirrels. These animals are dark-furred and have unusually long tails even for squirrels. They live exclusively in old-growth rainforest and are threatened by habitat loss. Scientists estimate that there may be only a few thousand individuals remaining in the wild. Variegated squirrels of Central America are among the most colorful squirrels in the world. Different populations have different color patterns, with some individuals displaying patches of white, black, brown, and even hints of red in their fur. No two variegated squirrels look exactly alike, and scientists believe this variation might have evolved as a form of individual recognition, helping these social animals identify each other within their groups. Urban squirrels and human coexistence. The relationship between squirrels and humans is ancient and complex. As humans have built cities and expanded into natural habitats, squirrels have followed, learning to exploit the resources that human presence provides. Today, urban squirrels are so common in many cities that people often forget these animals were once purely wild creatures of the forest. Urban squirrels behave differently from their rural counterparts in measurable ways. City squirrels tend to be bolder, approaching humans more closely and showing less fear response. This isn't just individual learning. Research has shown that urban squirrel populations have undergone evolutionary changes, with natural selection favoring individuals who are less skittish around humans. The timid squirrels avoid human-rich areas, while bold squirrels thrive, and they pass this boldness to their offspring. The diet of urban squirrels is more varied and, in some ways, more nutritious than wild squirrels. In addition to natural foods like acorns and nuts, city squirrels eat food from garbage cans, bird feeders, and intentional feeding by humans. While some of this food is unhealthy, urban parks often provide access to a wider variety of high-quality foods than would be available in a similar-sized wild territory. This is why urban squirrels often have higher survival rates and reproduce more successfully than rural squirrels. Urban environments present unique challenges for squirrels. Roads are particularly dangerous, and vehicle collisions are a leading cause of death for city squirrels. However, populations in older cities have shown adaptive behaviors, such as waiting at curbs before crossing and using power lines or fences as bridges over streets. In some cities, squirrels have learned to recognize the patterns of traffic lights and crossing signals, waiting for cars to stop before crossing roads. The trees in urban parks and along city streets provide habitat for squirrels, but these trees are different from forest trees. They're often spaced farther apart, requiring squirrels to travel on the ground more frequently, which increases predator risk. Urban trees are also typically pruned, reducing the number of natural cavities available for nesting. This is why urban squirrels more commonly build drays in tree branches rather than nesting in tree cavities. Human feeding of squirrels is a controversial topic. While many people enjoy feeding squirrels and watching them up close, wildlife experts generally discourage the practice. Feeding can make squirrels too comfortable around humans, leading to aggressive behavior when food isn't provided. It can also lead to nutritional problems if squirrels fill up on bread, crackers, or other foods that don't provide the nutrients they need. Additionally, concentrated feeding sites can spread disease as squirrels gather in unnaturally high densities. Despite these concerns, the presence of squirrels in urban areas provides benefits. Studies have shown that watching wildlife, including squirrels, reduces stress and improves mental health in city dwellers. Squirrels also provide ecosystem services in cities by planting trees, as the nuts they cache but never retrieve often germinate and grow. In this way, squirrels serve as unintentional gardeners, contributing to urban forest regeneration. The intelligence of urban squirrels is constantly tested by humans trying to protect bird feeders. This has led to an ongoing arms race, with people designing increasingly complex squirrel-proof feeders and squirrels learning to defeat these barriers. Videos of squirrels solving elaborate obstacle courses to reach birdseed have become internet sensations, demonstrating just how creative and persistent these animals can be when motivated by food. Cities also changed the social behavior of squirrels. In forests, squirrels maintain large territories and rarely tolerate other squirrels nearby except during mating season. In cities, where food is abundant and concentrated, squirrels live at much higher densities and show more tolerance for neighbors. Urban squirrels still defend core areas around their nests, but they share feeding sites with other squirrels more readily than forest squirrels would. The squirrel's body in detail. To truly understand squirrels, we must look closely at the remarkable anatomy that makes their lifestyle possible. Every part of a squirrel's body is optimized for their acrobatic, arboreal existence, from the tips of their claws to the end of their magnificent tail. The skeleton of a squirrel is a masterpiece of lightweight construction. Their bones are thin-walled and porous, reducing weight while maintaining strength. This is crucial for animals that spend their lives jumping and climbing. A squirrel's skeleton accounts for only about 10% of its total body weight, compared to about 15% in humans. Despite this lightness, squirrel bones are remarkably strong and flexible, allowing them to absorb the impact of falls and jumps. A squirrel's skull is shaped to accommodate their large eyes and powerful jaw muscles. The eye sockets are positioned to provide maximum field of view, and the brain case, though small, houses a brain that's large relative to body size compared to many other rodents. The lower jaw hinges far back on the skull, creating leverage that allows the jaw muscles to generate incredible crushing force for an animal of this size. The teeth of a squirrel deserve special attention. Besides their 4 prominent front incisors that grow continuously, squirrels have cheek teeth, premolars and molars used for grinding food. These cheek teeth don't grow continuously like the incisors. The incisors are covered with hard orange enamel on the front surface only. The back surface is softer dentine, which wears away faster, keeping the incisors sharp like self-sharpening chisels. A squirrel's forelimbs are shorter than their hind limbs, and each front paw has 4 long, curved claws plus a small thumb. This thumb isn't opposable like a human's, but it does help the squirrel manipulate objects with remarkable dexterity. Watch a squirrel eat a nut, and you'll see it rotate the nut in its paws, examining it from all angles and positioning it precisely before biting. The hind legs of a squirrel are powerful and heavily muscled, providing the explosive force needed for jumping. The ankle joint is particularly flexible, with a range of motion that allows the hind feet to rotate 180 degrees. This rotation is what enables squirrels to descend trees headfirst. As they climb down, they rotate their ankles backward so their hind claws can grip the bark while their heads point toward the ground. The claws themselves are sharp and curved, perfect for gripping bark. Unlike cat claws, squirrel claws aren't retractable, so they're always extended and ready for climbing. The claws grow continuously throughout a squirrel's life and are worn down through constant use. A squirrel that lives on soft surfaces without rough bark to climb would eventually develop claws so long they'd interfere with normal movement. The cardiovascular system of a squirrel is adapted for high activity levels. Their resting heart rate is around 200 beats per minute, and during exertion, it can exceed 400 beats per minute. Their blood is rich in red blood cells, allowing efficient oxygen delivery to muscles during the intense activity of climbing and jumping. Despite this high-energy lifestyle, squirrels have proportionally smaller hearts than similarly sized animals that are less active. The respiratory system is equally impressive. Squirrels have a high metabolic rate, requiring them to breathe rapidly. At rest, they take 30 to 40 breaths per minute. Their lungs are relatively large for their body size, and they can increase their breathing rate dramatically during activity. This efficient oxygen exchange supports their energetic lifestyle. The tail is perhaps the most distinctive feature of many squirrel species. A tree squirrel's tail can be as long as its entire body. The tail is essentially an extension of the spine, containing dozens of vertebrae. It's covered in long, fluffy fur that can be fluffed up or flattened. The muscles at the base of the tail allow precise control over its position and movement, enabling the tail to function as a balancing organ, communication device, and even a blanket. Communication and language. Squirrels possess a sophisticated communication system that combines vocalizations, tail movements, body postures, and scent marking. To another squirrel, these signals convey detailed information about identity, emotional state, intentions, and warnings about the environment. Understanding squirrel communication gives us a window into their complex social world. The vocal repertoire of squirrels is more extensive than most people realize. The most commonly heard is the kook call, a staccato chattering sound. This call indicates general alarm and is often given when a ground predator like a cat or fox is nearby. The rhythm and intensity of the cucks convey information about the level of threat. Slow, widely spaced cucks indicate moderate concern, while rapid-fire cucks signal high danger. The quaw call is a longer, more drawn-out sound that squirrels use in extremely threatening situations. This call is less common than cucks and typically indicates that a predator is very close or actively pursuing the squirrel. Other squirrels hearing a quaw call will immediately seek cover and remain still for an extended period. The seat call is high-pitched and whistle-like. Squirrels use this call specifically for aerial predators like hawks and eagles. The seat call is more difficult for predators to localize than lower-pitched calls, possibly making it safer for the squirrel to warn others without giving away its own position. This call sends all nearby squirrels running for cover or freezing in place against tree trunks. Squirrels also produce sounds that indicate contentment or social bonding. A soft purring or clicking noise is sometimes heard when a mother is with her young, or when squirrels are engaged in friendly social interaction. These gentle sounds are quiet and meant only for close-range communication, unlike alarm calls that carry for long distances. The tail is equally important in squirrel communication. A rapidly flicking tail indicates agitation or alarm. The faster the flicking, the more disturbed the squirrel. A tail held still and curved over the back is a sign of confidence and calm. A tail that's fluffed up and waved slowly is often seen during territorial disputes or courtship, making the squirrel appear larger and more impressive. During aggressive encounters, Squirrels combine vocalizations with specific body postures. An aggressive squirrel will face its opponent directly, flick its tail rapidly, and chatter loudly. It might also stomp its front feet or lunge forward without actually attacking. These displays often resolve conflicts without physical contact, as one squirrel backs down and leaves the area. Scent marking is the most subtle form of squirrel communication. Squirrels have scent glands on their cheeks, feet, and flanks. They leave chemical messages by rubbing these glands on tree bark, branches, and at cache sites. These scent marks convey information about the individual's identity, sex, reproductive status, and how recently they passed through an area. To a squirrel, a forest is covered in these invisible messages, creating a chemical landscape of information. Foot drumming is another communication method, particularly common in some ground squirrel species. When alarmed, these squirrels drum their hind feet rapidly against the ground or against a tree branch. The vibrations carry through the substrate and can be detected by other squirrels, providing a warning signal that works even when visual or vocal communication might be blocked. The complexity of squirrel communication suggests these animals have rich mental lives and social awareness. They're not just reacting automatically to stimuli but making decisions about what information to share, with whom, and how urgently. The fact that different squirrel populations have slight variations in their calls, essentially dialects, further indicates that squirrel communication is learned and socially transmitted rather than purely instinctual. Reproduction and family life. The reproductive cycle of squirrels is timed to give their young the best chance of survival. In most temperate regions, squirrels have 2 breeding seasons per year, one in late winter and another in midsummer. This timing ensures that babies are born when weather is moderate and food will be increasingly available as they grow. The winter mating season begins as early as December in some regions and can extend through February. During this time, male squirrels become intensely focused on finding receptive females. A female is only receptive to mating for a few hours on a single day, so males must be vigilant. They can detect the pheromones of a female approaching estrus and will begin gathering near her territory days before she's ready to mate. When the crucial day arrives, multiple males will compete for the female's attention in elaborate mating chases that can last for hours. The female leads the pursuit, running through the trees with sometimes half a dozen males following behind. This chase serves multiple purposes. It allows the female to assess which males are the fittest and most persistent, it synchronizes her reproductive physiology, and it may even serve to stimulate ovulation. The chase is not without danger. Males so focused on pursuing a female sometimes miscalculate jumps or fail to notice predators. Falls are common, and occasionally males are picked off by hawks who have learned to hunt near mating chases when squirrels are distracted. Despite these risks, the males persist, driven by the biological imperative to reproduce. Eventually, the female will allow one male to approach closely, typically the largest, most dominant male who has proven himself through the chase. Mating itself is brief, lasting only a few seconds. However, the female may mate with multiple males over the course of her receptive period. This leads to litters where different young have different fathers, a strategy that may ensure genetic diversity and healthy offspring. After mating, the female drives all males away from her territory. She becomes aggressive toward any squirrel that approaches, regardless of sex. She needs exclusive access to her territory's food resources during pregnancy and while nursing, and she cannot afford to share with competitors. The males, having accomplished their reproductive goal, return to their own territories and take no part in raising the young. The pregnant female spends the next 6 weeks preparing for her litter. She modifies her maternal dray, making it larger, softer, and more secure than her regular nest. She lines it with the finest materials she can find, shredded bark, soft moss, for she grooms from her own body, and sometimes soft materials stolen from human sources like insulation or fabric. Squirrel litters typically contain 2 to 6 babies, depending on the species and the mother's health and age. First-time mothers usually have smaller litters, while experienced mothers in prime condition may have larger ones. The babies are born utterly helpless, weighing less than an ounce each, hairless, blind, and deaf. They're entirely dependent on their mother for warmth, food, and protection. For the first few weeks, the mother leaves the nest only briefly to forage for food, rushing back to keep her babies warm. Baby squirrels cannot regulate their own body temperature and will die if they get too cold. The mother spends most of her time curled around her litter, nursing them and keeping them warm. She's extremely protective during this period and will attack much larger animals if they approach her nest. From helpless to independent. The development of baby squirrels follows a predictable but remarkable progression. At birth, they're pink, wrinkled, and barely recognizable as squirrels. Their eyes are sealed shut, their ears are closed, and they have no fur. They measure only a few inches long, and their tails are just tiny nubs. In this vulnerable state, they instinctively crawl toward warmth and begin nursing within hours of birth. By the end of the first week, the babies have gained weight and their skin has darkened. Fine fur begins to appear on their bodies, though they're still essentially hairless. Their claws, however, are already sharp and well-developed, allowing them to grip their mother's fur. They spend their days sleeping in a pile, waking to nurse frequently. Their mother keeps the nest meticulously clean, consuming the baby's waste to prevent odors that might attract predators. At 2 weeks old, the babies are covered in short, soft fur, though their eyes and ears remain closed. They're more active now, crawling around the nest and beginning to interact with their siblings. Play behavior starts to emerge as they nuzzle and climb over each other. They're growing rapidly, doubling their birth weight every few days. The momentous day when a baby squirrel's eyes open occurs around 4 to 5 weeks of age. This marks a dramatic shift in their development. Suddenly, they can see their mother, their siblings, and the nest around them. Their ears open around the same time, filling their world with sound. These newly activated senses are initially overwhelming, and the babies spend days just observing, learning to process visual and auditory information. At 6 weeks, the babies begin to develop their distinctive bushy tails, though they're still much shorter and less fluffy than adult tails. Their baby teeth have erupted, and they begin experimenting with solid foods that their mother brings to the nest. They're not yet weaned, still nursing regularly, but these first solid meals teach them what foods are safe and desirable. 7 to 8 weeks old marks another major transition. The babies venture outside the nest for the first time. These initial explorations are tentative and closely supervised by the mother. The babies stay on branches immediately adjacent to the nest entrance, simply observing the world around them. Everything is new: the feel of the breeze, the movement of leaves, the sounds of the forest. They're easily startled and rush back into the nest at the slightest disturbance. Over the next few weeks, the young squirrels become increasingly bold and competent. They practice jumping, at first making tiny hops between adjacent branches, gradually building their confidence and skill. They chase each other around the tree in games that look like pure play but actually teach crucial survival skills. They learn to judge distances, develop coordination, and build the muscle memory needed for their acrobatic lifestyle. Weaning occurs gradually over several weeks, starting around 10 weeks of age. The mother begins discouraging nursing attempts, spending more time away from the nest, and bringing less food to her young. The babies are forced to forage for themselves, initially staying close to home and eating easy-to-gather foods like tender buds and soft fruits. The mother tolerates them in her territory during this learning period, but her patience is not infinite. By 12 to 14 weeks old, the young squirrels are essentially independent, though still smaller than adults. The mother becomes increasingly intolerant of their presence, chasing them away when they approach too closely. This rejection seems harsh, but it's necessary. If the young don't disperse, they'll compete with their mother for food and may not develop the self-reliance needed to survive on their own. The ecological role of squirrels. Squirrels are far more than just entertaining visitors to our parks and backyards. They play crucial roles in forest ecosystems, affecting everything from tree populations to nutrient cycling. Understanding these ecological roles helps us appreciate how interconnected natural systems truly are. Perhaps the most important ecological role squirrels play is as tree planters. A single gray squirrel can cache as many as 10,000 nuts in a single autumn. While they recover about 80% of these caches, that leaves 2,000 nuts buried in perfect conditions for germination. Each year, squirrels inadvertently plant thousands of trees across their territories. Many of the oak, hickory, and walnut trees in our forests today exist because a squirrel buried a seed and forgot to retrieve it. This seed dispersal service is particularly important for trees that produce large seeds. Acorns are too heavy to be carried far by wind, and many simply fall beneath their parent tree where they must compete for light and nutrients. Squirrels gather these acorns and cache them at distances of up to several hundred feet from the parent tree, effectively distributing the next generation of trees across the landscape. Squirrels are selective about which seeds they cache where, and this selectivity shapes forest composition. They prefer to eat certain species immediately while caching others for later. White oak acorns, which have lower tannin content, are typically eaten right away. Red oak acorns, which store better due to their higher tannin content, are more likely to be cached. This means red oaks may have an advantage in colonizing new areas, as their seeds are more likely to be transported and buried. The feeding activities of squirrels also affect fungal populations in forests. Many species eat mushrooms and truffles extensively, and the fungal spores pass through their digestive systems intact. As squirrels move through the forest and defecate, they spread these spores, helping fungi colonize new areas. The relationship between trees, fungi, and squirrels is complex. Many trees depend on mycorrhizal fungi for nutrient uptake, fungi depend on trees for energy, and squirrels help maintain and spread the fungal partners that trees need. Squirrels serve as prey for a wide variety of predators, making them an important link in the food web. They convert plant materials, nuts, seeds, bark, into animal protein that's then available to carnivores. In many ecosystems, squirrels are the primary prey species for medium-sized predators like hawks, owls, foxes, and bobcats. A decline in squirrel populations can cascade through the ecosystem, affecting predator populations and even influencing the abundance of other prey species. The building of drays by tree squirrels creates habitat for other animals. Abandoned drays are often taken over by other species including birds, flying squirrels, and even small mammals like white-footed mice. The drays themselves decompose slowly, adding organic matter to the soil below. Squirrels also create cavities in trees by chewing bark, and these cavities may later be used by birds, bats, or other cavity-nesting species. Ground squirrels have their own ecological impacts. Their burrowing mixes and aerates soil, improves water infiltration, and brings nutrients from deep soil layers to the surface. Prairie dog colonies, in particular, create islands of increased plant diversity and productivity. The disturbed soil around burrow entrances supports different plant species than the surrounding grassland, and the frequent clipping of vegetation by prairie dogs prevents any single plant species from dominating. Squirrels also affect nutrient cycling in forests. They consume large quantities of plant material and concentrate nutrients in their drays and feeding sites. Their cached nuts often decompose in place if not retrieved, returning nutrients to the soil. Their impact on tree mortality is also significant. In years when squirrel populations are high, they can consume virtually all seed production from certain tree species, potentially affecting forest regeneration patterns. The presence of squirrels can even affect the behavior and distribution of other species. Some bird species avoid nesting in areas with high squirrel populations because squirrels raid nests for eggs and chicks. Some plants have evolved defenses specifically against squirrel predation, such as increasing tannin content in seeds or producing seeds in mass years, overwhelming the ability of squirrels to consume or cache them all. Squirrels and seasonal adaptations. The ability of squirrels to survive the dramatic seasonal changes in temperate regions requires remarkable physiological and behavioral adaptations. As the year progresses through its cycle, squirrels transform their bodies, their behaviors, and their priorities to match each season's demands. Winter survival begins with preparation in autumn. As day length shortens, hormonal changes trigger hyperphagia, the intense feeding and caching behavior we've discussed. But physical changes are occurring too. Squirrels grow thicker winter coats, adding a dense undercoat beneath their guard hairs. This winter pelage can be twice as thick as their summer coat, providing crucial insulation. The color often changes slightly too, with gray squirrels becoming grayer and red squirrels developing more prominent ear tufts. The paws of squirrels also change with seasons. In winter, the hair on their feet grows thicker, providing both insulation and better grip on icy branches. Some species develop hair on the bottoms of their feet that's almost snowshoe-like, distributing their weight across soft snow. This adaptation is particularly pronounced in northern species like the red squirrel. Behavioral changes complement these physical adaptations. In the coldest parts of winter, squirrels reduce their activity levels dramatically. They may remain in their drays for days during severe cold snaps, living off their body fat and venturing out only when temperatures moderate. This torpor-like state isn't true hibernation, as they can wake quickly, but it conserves energy when foraging would cost more calories than it would provide. Squirrels also change their activity patterns in winter. Instead of being most active at dawn and dusk, they shift their activity to midday when temperatures are warmest. You're more likely to see squirrels out at noon on a winter day than at dawn, the opposite of their summer pattern. This scheduling reduces the energy needed to maintain body temperature while active. Spring brings a dramatic increase in activity and energy demands. For females, pregnancy and nursing require enormous resources. Lactating female squirrels need to consume up to 3 times their normal food intake. They feed heavily on high-protein foods like insects, bird eggs, and new plant growth, supplementing these with stored nuts from the previous fall. Males in spring are focused on territory defense and seeking mating opportunities. Spring territories tend to be larger than winter territories as squirrels spread out to take advantage of new food resources appearing across the landscape. Young squirrels dispersing from their birth territories add to the social complexity, as established adults must defend their ranges from these newcomers. Summer presents different challenges, primarily heat management. Squirrels don't sweat as humans do. Instead, they regulate temperature through behavioral adaptations and by increasing blood flow to their extremities, particularly their tails and ears. You'll see squirrels lying sprawled flat on cool surfaces in summer, maximizing contact with cooler substrates. They also become less active during the hottest parts of the day, retreating to the shade. Summer is also when second litters are born in many populations. While not all female squirrels breed twice per year, those in good condition with access to abundant resources often do. These summer babies face different challenges than spring litters, developing during the hottest months but also maturing when fall's abundant food is available to help them build reserves before their first winter. As summer transitions to autumn, squirrels must make critical decisions about their upcoming molt. They shed their summer coat and grow their winter pelage, a process that requires significant energy and protein. The timing is crucial. Molt too early and they waste energy staying warm during still hot late summer days. Molt too late and they face early cold snaps without adequate insulation. Photoperiod, the length of daylight, provides the primary cue for when to begin molting. Health, disease, and lifespan. Like all wild animals, squirrels face numerous health challenges throughout their lives. Understanding these challenges provides insight into the harsh realities of survival in the wild and the remarkable resilience these animals demonstrate. Parasites are perhaps the most common health issue facing squirrels. Fleas, ticks, mites, and lice infest both the fur and skin of most wild squirrels. While a few parasites don't significantly impact a healthy squirrel, heavy infestations can cause anemia, skin irritation, and secondary infections. Squirrels regularly groom themselves and each other, using their claws and teeth to remove parasites, but they can never eliminate them entirely. Internal parasites are equally common. Many squirrels harbor intestinal worms, protozoans, and other parasites that live in their digestive systems. Some of these parasites have evolved specifically to infect squirrels, while others are generalists that infect many mammal species. Again, light parasitic loads typically don't significantly harm healthy squirrels, but weakened individuals can suffer severe impacts. Warbles are a particularly noticeable parasitic infection. These are the larvae of botflies that burrow under a squirrel's skin and grow there, creating large bumps. While they look horrifying to humans, squirrels with warbles usually remain active and healthy. Once the larva matures, it drops out, and the wound heals. Most squirrels that survive to adulthood have been infected with warbles at least once. Fungal infections can affect squirrels, particularly skin infections that cause hair loss. Mange, caused by mites, is sometimes mistaken for fungal infection. Squirrels with mange lose their fur in patches, and severe cases can lose most of their fur. A hairless squirrel in winter faces enormous challenges, as it loses the insulation needed to survive cold weather. Many mange-infected squirrels don't survive the winter. Squirrels can contract various viral and bacterial diseases. Squirrelpox, mentioned earlier, is a virus particularly devastating to red squirrels, though gray squirrels carry it without symptoms. Other viral diseases include various forms of pox and, rarely, rabies. Bacterial infections can occur from wounds, particularly bite wounds from fighting with other squirrels or escaping from predators. Dental problems pose serious risks to squirrels. If an incisor is broken or grows incorrectly, it may not wear against its opposite tooth properly. This can lead to overgrowth, where the tooth grows so long the squirrel can't close its mouth properly or can't crack nuts. A squirrel with severe dental problems will starve unless the overgrown tooth breaks off naturally. Injuries from falls, predator attacks, and fights with other squirrels are common. Squirrels heal remarkably well from many injuries that would be fatal to less resilient animals. Broken bones often heal on their own, though sometimes imperfectly, resulting in squirrels with crooked limbs or tails. Even squirrels missing feet or significant portions of their tails can survive and live relatively normal lives if they adapt to their disability. The maximum lifespan of squirrels varies by species and living conditions. In the wild, gray squirrels rarely live beyond 6 years, with most dying in their first year. Red squirrels live slightly longer, occasionally reaching 8 to 10 years in the wild. Ground squirrels that hibernate tend to have shorter active lifespans, though they may live many calendar years due to spending much of that time hibernating. In captivity, protected from predators and with consistent food and veterinary care, squirrels can live dramatically longer, with some individuals exceeding 20 years. The primary causes of death for wild squirrels vary by age. For young squirrels, predation, starvation, and exposure are the main threats. Adults are most likely to die from predation, though accidents, disease, and starvation during harsh winters also take their toll. Very few squirrels die of old age in the wild. Most are killed by predators while they're still reproductively active. Remarkable squirrel behaviors. Beyond their well-known nut-caching behavior, squirrels display numerous fascinating behaviors that reveal their intelligence and adaptability. These behaviors have evolved over millions of years, fine-tuned by natural selection to enhance survival and reproductive success. One intriguing behavior is called deceptive caching, which we've touched on before, but deserves deeper exploration. When a squirrel knows it's being watched by potential cache robbers, it doesn't just create fake caches. It engages in an elaborate performance, going through all the motions of digging, depositing, and covering a nut while keeping the actual nut in its mouth. After the observer leaves, the squirrel returns and actually buries the nut elsewhere. This behavior requires the squirrel to understand that other animals have perspectives and intentions different from its own, a cognitive ability called theory of mind that was once thought unique to primates. Squirrels also engage in something called cache protection strategies. They'll vary their caching behavior based on how valuable a food item is. High-value foods like walnuts and pecans are buried farther from the source and in more concealed locations than lower-value foods like acorns. They'll also spend more time and effort burying valuable foods deeper and covering them more thoroughly. This suggests squirrels can assess the relative value of different foods and adjust their behavior accordingly. Sunbathing is a behavior commonly observed in squirrels, particularly in early morning. They'll sprawl out on branches or rooftops, exposing their bellies to the sun. This behavior serves multiple purposes. It warms their bodies, reducing the energy needed to maintain body temperature. It may also help control parasites, as many parasites are less active or die in heat and direct sunlight. Additionally, sun exposure helps squirrels synthesize vitamin D, essential for bone health. Squirrels engage in what scientists call self-anointing behavior, particularly when they encounter strong-smelling substances. They'll chew on the material, often something aromatic like tree sap, mushrooms, or even discarded snake skin, then spread the resulting saliva mixture through their fur. The purpose of this behavior isn't entirely clear, but theories include parasite control, scent masking from predators, or social signaling to other squirrels. Tail flagging serves multiple communicative purposes we've mentioned, but the sophistication of this signal deserves more attention. The speed, amplitude, and pattern of tail movements convey different messages. A slow, undulating wave differs from a rapid flick, which differs from a brief twitch. Squirrels can modulate these signals based on the situation, the intended recipient, and the urgency of the message. Young squirrels must learn the nuances of tail flagging through observation and practice. Caching priority is another complex behavior. When presented with multiple food items, squirrels don't cache randomly. They first eat the most perishable foods, then cache foods based on their storability and nutritional density. Pine cones might be cached immediately because they're bulky and difficult to carry. Nuts are evaluated individually, with damaged or insect-infested ones eaten immediately and perfect specimens cached for later. This decision-making happens rapidly, with squirrels assessing each item in seconds. Squirrels demonstrate what researchers call trade-off decisions constantly throughout their days. Every choice involves weighing costs and benefits. Should I spend more time searching for a higher quality food, or settle for the adequate food I've already found? Should I flee from this potential threat and abandon my current meal, or stay and continue eating while monitoring the danger? Should I chase that intruder for my territory, or ignore them to avoid the energy cost and injury risk of a fight? The fact that squirrels make these complex decisions adaptively, changing their choices based on context, demonstrates sophisticated cognitive processing. Some urban squirrels have learned to exploit human behaviors in creative ways. In parks where people regularly feed squirrels, some individuals have learned to approach humans with specific begging behaviors, like standing upright on their hind legs or making eye contact. These behaviors are more effective at eliciting food from humans than simply approaching, and squirrels that use them successfully may pass these techniques to their offspring through observation learning. Squirrels also show remarkable problem-solving flexibility. When presented with novel challenges, like new types of bird feeders or food sources, squirrels experiment with different approaches. They'll try multiple strategies, remember which ones work, and even combine successful techniques in new ways. This behavioral flexibility is a hallmark of intelligence and helps explain how squirrels have successfully colonized such diverse habitats, from dense forests to urban centers. Squirrel senses in detail. To truly appreciate how squirrels experience the world, we need to understand their sensory capabilities in depth. Each sense is finely tuned to provide the information squirrels need to survive, find food, avoid predators, and communicate with each other. Vision in squirrels is optimized for their arboreal lifestyle. Their eye placement provides a panoramic field of view, allowing them to monitor nearly their entire surroundings simultaneously. This comes at a cost. They have limited binocular vision directly in front of them, meaning they have less depth perception than humans. However, squirrels compensate by bobbing their heads to see objects from multiple angles, creating depth information through motion parallax. The retinas of squirrel eyes contain a high density of rod cells, which detect light and motion, and a moderate density of cone cells, which detect color. This combination gives squirrels good vision in low light conditions, important for crepuscular animals active at dawn and dusk. Their color vision is dichromatic, meaning they have two types of color receptors rather than the three humans possess. Squirrels see blues and greens well but have difficulty distinguishing reds from greens, seeing them as similar shades of yellow. Squirrels possess a tapetum lucidum, a reflective layer behind the retina that bounces light back through the photoreceptors. This adaptation enhances vision in low light by giving photoreceptors a second chance to capture photons. It's this structure that causes eye shine when you illuminate a squirrel's eyes with a flashlight at night, though the effect is less dramatic than in animals like cats or deer. The sense of smell in squirrels is extraordinarily discriminating. Their nasal cavities contain complex turbinate bones covered in olfactory epithelium, the tissue containing smell receptors. Squirrels have far more olfactory receptors than humans, allowing them to detect odors we can't perceive and to distinguish between very similar scents. This ability is crucial for relocating cached nuts, detecting predators, and assessing the reproductive status of other squirrels. Squirrels can smell nuts buried under a foot of snow or 6 inches of soil. But they're not just detecting the nut itself. Research suggests they may also be detecting the odor of disturbed soil, the metabolic byproducts of decomposing leaf litter around the cache, or even slight differences in soil microbe populations at cache sites. Whatever the exact mechanism, this olfactory precision is remarkable. The vomeronasal organ, also called Jacobson's organ, is present in squirrels as in many mammals. This specialized structure detects pheromones and other chemical signals. Squirrels use it to gather information about other squirrels' reproductive status, stress levels, and individual identity. When you see a squirrel pause and seem to taste the air with its mouth slightly open, it's often using its vomeronasal organ to sample chemical signals. Hearing in squirrels covers a broader frequency range than human hearing, extending well into ultrasonic ranges. They can hear sounds up to 50 kHz, compared to the human upper limit of about 20 kHz. This extended range allows them to hear the high-frequency distress calls of baby squirrels, the ultrasonic vocalizations of some predators, and possibly even the high-frequency sounds made by insects moving in tree bark. The ear structure of squirrels is adapted for locating sounds precisely. They can independently orient each ear toward different sound sources, and their brain processes the tiny differences in timing and intensity between the two ears to triangulate sound locations. This ability is crucial for detecting predators and locating other squirrels even when visual contact isn't possible. Touch receptors are distributed across a squirrel's body, but particularly concentrated in several key areas. The whiskers on the face, called moustachial vibrissae, are extremely sensitive and can detect air currents, helping squirrels navigate in darkness or through dense vegetation. The whiskers on the wrists, called carpal vibrissae, help squirrels judge branch diameter and texture while climbing. Even the tail has touch-sensitive hairs that provide information about air movement and contact with objects. The sense of taste in squirrels helps them evaluate food quality and avoid toxic plants. Squirrels can detect bitter compounds, which often indicate toxins, sweet compounds indicating sugars and energy, and umami tastes associated with proteins. They use taste to assess nut quality even before cracking them open, and they'll reject bitter or off-tasting foods that might be spoiled or toxic. Proprioception, the sense of body position and movement, is exceptionally well developed in squirrels. This internal sense tells them exactly where each part of their body is in space, allowing them to make precise movements while jumping, climbing, and landing. The cerebellum, the brain region processing proprioceptive information and coordinating movement, is proportionally large in squirrels compared to less acrobatic mammals. Balance is maintained through the vestibular system in the inner ear, which detects head position and movement. For squirrels running along narrow branches and leaping through trees, this system must provide accurate information at high speeds. The squirrel's tail also contributes to balance, acting as a counterweight that can be repositioned rapidly to maintain stability during complex maneuvers. Squirrels in mythology and culture. Throughout human history, squirrels have captured our imagination and found their way into our myths, stories, and cultural traditions. These small animals have carried symbolic meanings in diverse cultures, often representing qualities like preparation, playfulness, and resourcefulness. In Norse mythology, a squirrel named Ratatoskr runs up and down Yggdrasil, the world tree that connects all realms of existence. Ratatoskr's role is to carry messages between the eagle that sits atop the tree and the dragon that gnaws at its roots. However, these aren't friendly messages. Ratatoskr is said to stir up trouble by exaggerating and distorting the messages, causing the eagle and dragon to exchange insults. This myth portrays the squirrel as a clever but mischievous messenger, running between heaven and earth. In Native American traditions, squirrels appear in various stories across different tribes. Some traditions portray squirrels as planners and preparers, gathering and storing food as an example for humans to follow. Others tell stories of squirrels as tricksters or gossips, chattering and spreading news through the forest. The Cherokee tell stories of how the squirrel got its bushy tail, usually involving the squirrel's vanity or cleverness leading to its distinctive appearance. Japanese culture has a complicated relationship with squirrels. The Japanese squirrel is considered cute and appears in art and literature as a symbol of the changing seasons, particularly autumn when they're most visible gathering nuts. However, the more recent introduction of non-native squirrel species has created ecological problems, leading to more negative associations in modern times. Traditional Japanese art often depicts squirrels among grapevines, a classic aesthetic combination. In medieval European bestiaries, Squirrels were sometimes used as symbols of avarice or hoarding due to their food-storing behavior. However, they were also admired for their foresight and preparation. Medieval art occasionally depicted squirrels in religious contexts, though their meaning was ambiguous. Red squirrels in particular appeared in illuminated manuscripts, their bright color making them visually striking subjects. The squirrel as a symbol of preparation and planning appears in Aesop's fables and similar moral tales. While Aesop himself didn't write specifically about squirrels, they weren't native to ancient Greece. Later fable writers in northern regions added squirrel tales that paralleled the famous ant and grasshopper story. The squirrel became associated with wise preparation for hard times ahead. In modern Western culture, squirrels have become symbols of suburban and park life, sometimes viewed as charming wildlife neighbors and sometimes as nuisances. This dual perception reflects the complex relationship between humans and wildlife in urban and suburban environments. Squirrels appear frequently in children's literature and animation, usually portrayed as energetic, slightly chaotic characters, reflecting their frenetic behavior in real life. The squirrel has been adopted as a mascot by numerous universities, sports teams, and organizations. These adoptions often emphasize qualities like agility, tenacity, and resourcefulness. The squirrel's ability to thrive in human-modified environments has made it a symbol of adaptability and persistence in the face of change. Popular culture has created memorable fictional squirrels that have influenced public perception of these animals. From the hyperactive Scrat in the Ice Age films to the neurotic squirrel from The Emperor's New Groove, these portrayals exaggerate real squirrel behaviors like food obsession and nervous energy for comedic effect. While not scientifically accurate, they've increased public awareness and affection for squirrels. The phrase, squirreling away, has entered the English language as a metaphor for saving or hoarding resources for future use. This linguistic legacy demonstrates how deeply squirrel behavior has influenced human culture. Other squirrel-related expressions like squirrely, meaning nervous or unpredictable, also reflect observed squirrel behaviors that humans have found notable enough to incorporate into language. Conservation and human impact. While many squirrel species remain abundant, human activities have significantly impacted squirrel populations worldwide, both negatively and, in some cases, positively. Understanding these impacts is crucial for ensuring that future generations can continue to enjoy these remarkable animals. Habitat loss is the primary threat facing many squirrel species. As forests are cleared for agriculture, development, and logging, squirrels lose not just their homes but their food sources and protection from predators. Tree squirrels need mature forests with nut-producing trees, and these forests take decades or centuries to develop. Ground squirrels require grasslands and meadows that are increasingly converted to farmland or urban development. Some squirrel species have incredibly restricted ranges, making them particularly vulnerable to habitat loss. The Delmarva Peninsula fox squirrel was once common throughout the Delmarva Peninsula on the U.S. East Coast but declined dramatically due to deforestation. Conservation efforts, including habitat protection and reintroduction programs, have helped this species recover, and it was removed from the endangered species list in 2015, a rare conservation success story. Introduced species have caused problems for native squirrels in several regions. The introduction of American gray squirrels to Britain and Italy has led to dramatic declines in native red squirrel populations. Gray squirrels are larger, more adaptable, and carry diseases that don't affect them but are fatal to red squirrels. Efforts to control gray squirrel populations and protect remaining red squirrel refuges continue, but the challenge is immense. Climate change is affecting squirrel populations in complex ways. Warmer temperatures are shifting the ranges of some species northward or to higher elevations. Changes in temperature patterns affect the timing of food availability, potentially creating mismatches between when squirrels need food and when it's available. Altered weather patterns can impact survival, particularly for young squirrels or during critical periods like winter. In some cases, human activity has actually benefited certain squirrel species. The eastern gray squirrel has thrived in urban and suburban environments, with populations in parks and cities often exceeding natural forest densities. The provision of bird feeders, although unintentional, provides supplemental food. The planting of ornamental nut trees in parks and along streets has created habitat where none existed before. Some squirrel populations are healthier in human-modified landscapes than in natural ones, though this success is limited to highly adaptable species. Road mortality is a significant cause of death for squirrels in developed areas. Squirrels crossing roads face risks from vehicles, and their instinct to freeze when threatened or to zigzag when fleeing often makes them more vulnerable rather than less. In some high-traffic areas, roads effectively fragment squirrel populations, preventing gene flow between groups on either side of busy streets. Poison intended for rats and mice can also kill squirrels, either through direct consumption or by eating poisoned prey. Rat poison is designed to be attractive and palatable, and squirrels will readily eat it if they encounter it. The use of rodenticides in areas where squirrels live raises ethical questions about acceptable levels of non-target species mortality. Hunting of squirrels continues in many regions, both for sport and for food. Squirrel meat is actually quite nutritious and has been a traditional food source in many rural areas. Properly managed hunting can be sustainable and doesn't typically threaten squirrel populations, as squirrels reproduce quickly. However, overhunting combined with habitat loss can create problems for local populations. Some conservation efforts focus specifically on squirrels. Habitat protection, particularly of old-growth forests and mature woodlands, benefits squirrels along with many other species. Nest box programs provide artificial nesting sites in areas where natural tree cavities are scarce. Wildlife corridors that allow animals to move safely between habitat patches help maintain genetic diversity in squirrel populations. Citizen science projects engage the public in monitoring squirrel populations and behavior. Projects like iNaturalist encourage people to document squirrel sightings, contributing to our understanding of squirrel distribution and abundance. These programs also help educate the public about wildlife and foster appreciation for the animals living among us. Specialized squirrel species. Among the 200-plus species of squirrels, some have evolved remarkable specializations that allow them to thrive in unique environments or exploit unusual food sources. These specialists demonstrate the incredible adaptability of the squirrel family. The African pygmy squirrel, one of the smallest squirrels in the world, has adapted to life in the lower levels of West African rainforests. Weighing barely more than a chickadee, these tiny squirrels have proportionally larger eyes than their bigger cousins, helping them see in the dim light of the forest understory. They feed primarily on insects and tree sap, using their small size to access food sources on twigs too thin to support larger animals. At the opposite extreme, the Indian giant squirrel can weigh up to 4 pounds and measure 3 feet from nose to tail tip. These spectacular animals display vibrant colors unusual among squirrels: rich maroons, deep purples, and cream markings. They live exclusively in the canopy of Indian forests, rarely descending to the ground. Their large size allows them to defend feeding territories against other squirrels and to access hard-shelled nuts that smaller species cannot crack. The tufted ground squirrel of Borneo is so rare and secretive that scientists know almost nothing about its behavior in the wild. It has an extraordinarily bushy tail, proportionally larger than any other squirrel species, accounting for 130% of its body volume. Local legends claim these squirrels kill and eat deer, though scientists are skeptical. The truth is, we simply don't know what this mysterious squirrel eats or how it lives. Chipmunks, which are actually small ground squirrels, have cheek pouches that can expand to 3 times the size of their heads. These pouches allow them to transport large quantities of food efficiently. A chipmunk can stuff dozens of seeds or nuts into its cheeks, carry them to its burrow, empty its pouches, and return for more, making multiple trips per hour during peak foraging season. The woolly flying squirrel of Pakistan and the Himalayas is one of the rarest mammals in the world. Thought extinct for decades, it was rediscovered in the 1990s. These enormous flying squirrels can weigh up to 6 pounds and have exceptionally thick fur for insulation in their cold mountain habitat. They glide between pine trees in high-altitude forests, though almost nothing else is known about their ecology due to their rarity and the remote, difficult terrain they inhabit. Rock squirrels of the American Southwest have adapted to life in rocky, arid environments where trees are scarce. They shelter in rock crevices and burrows among boulders, emerging to forage for seeds, cactus fruits, and insects. These large, mottled gray-brown squirrels can survive in deserts where many other squirrels would perish, obtaining most of their water from the food they eat. The red-cheeked squirrel of Borneo and nearby islands is notable for its social behavior. Unlike most squirrels, which are relatively solitary, these squirrels live in groups and share nesting sites. They communicate frequently with chirps and calls, maintaining contact even when foraging separately. The evolutionary pressures that led to this unusual social system aren't fully understood. The Malabar giant squirrel of India is famous not just for its size but for its spectacular coloring. Different populations display different color patterns, but most individuals have patches of black, brown, and cream or orange. They construct multiple drays throughout their territories, some of which are enormous structures that can be 2 feet in diameter. They're known for their shyness, freezing motionless against tree trunks when they detect observers. Alpine marmots, which are actually large ground squirrels, have evolved to survive in high mountain meadows. They live in family groups in extensive burrow systems, hibernating together for up to 9 months each year. Their social bonds are strong, with individuals taking turns standing guard while others feed. The alarm whistle of a marmot, warning of approaching predators, is one of the characteristic sounds of alpine environments. The 13-lined ground squirrel has evolved an unusual pattern for a mammal, alternating stripes and spots running down its back. This pattern may provide camouflage in the dappled light of prairie grass. These squirrels are efficient predators of insects, particularly grasshoppers, and their diet is more carnivorous than most squirrel species. They play an important role in controlling insect populations in grassland ecosystems. The physics of squirrel movement. The acrobatic abilities of squirrels aren't just impressive to watch, they're feats of physics that scientists have studied to understand how these small mammals accomplish such remarkable physical achievements. When a squirrel prepares to jump, it's solving a complex physics problem in fractions of a second. It must account for the distance to the target, the springiness and stability of its launch branch, the springiness of the landing branch, wind speed and direction, and its own velocity. Research using high-speed cameras has revealed that squirrels adjust their launch angle and power based on distance, using steeper angles for shorter jumps and shallower angles for longer leaps. The legs of a squirrel function like springs, storing and releasing elastic energy. When a squirrel crouches before a jump, it's loading these springs. The tendons and muscles in their legs can store energy elastically, then release it explosively, propelling the squirrel through the air with more force than muscle contraction alone could provide. This elastic storage mechanism is similar to how kangaroos hop or how humans run. During flight, a squirrel's tail serves as an active control surface. High-speed footage shows squirrels constantly adjusting their tail position mid-jump, using it to modify their trajectory. If a squirrel launches and realizes it's going to fall short of its target, it can extend its tail upward and forward, which shifts its center of mass and changes its rotation, sometimes providing just enough adjustment to reach the branch. The landing is perhaps the most physically impressive part of a jump. Squirrels can absorb impacts from jumps and falls that would injure or kill other animals of similar size. Their bodies are designed to dissipate impact forces. Flexible joints, strong but elastic bones, and a light overall structure all contribute. When landing, squirrels don't just grab with their claws, they allow their entire body to compress and flex, spreading the impact over time and reducing peak forces on any single body part. Rotational physics plays a crucial role in squirrel acrobatics. Like cats, squirrels possess what's called an aerial righting reflex, allowing them to reorient their bodies during a fall to land feet first. They accomplish this by rotating different parts of their body at different rates, conserving angular momentum while changing their overall orientation. The tail is crucial to this maneuver, acting as a counterweight. The terminal velocity of a falling squirrel is relatively low due to their high surface area to mass ratio. Their large tail and relatively light body create significant air resistance. A squirrel falling from any height will reach terminal velocity at around 24 miles per hour, slow enough that their bodies can absorb the impact. This is why squirrels can survive falls from remarkable heights, occasionally falling from tall buildings and walking away uninjured. Squirrels use their claws with remarkable precision. Each claw is curved and sharp, able to catch on tiny irregularities in bark. The force a squirrel can generate by gripping is impressive relative to their size. Tests have shown squirrels can support many times their body weight by clinging to vertical surfaces, and they can hang upside down from a branch using just their hind claws while manipulating food with their front paws. The biomechanics of gnawing reveal another physical adaptation. When a squirrel chews, its jaw moves not just up and down but also forward and backward. This protractive and retractive movement allows the incisors to work like chisels, shaving away material efficiently. The jaw muscles can generate bite forces of over 20 pounds per square inch, concentrated on the tiny edge of the incisor teeth, creating tremendous pressure capable of cracking hard nut shells. Balance is maintained through constant micro-adjustments. Squirrels running along narrow branches make tiny corrections multiple times per second, detected by their vestibular system and proprioceptors and executed by their muscles. This feedback loop happens faster than conscious thought, operating at a reflexive level that allows squirrels to maintain balance even while moving at high speeds. The energy efficiency of squirrel movement is remarkable. Squirrels don't waste energy on unnecessary movements. Their travel through trees follows efficient paths, and they use the springiness of branches to assist their movement, bouncing from flexible branches to add momentum. When moving between trees, squirrels often follow the same routes repeatedly, learning which branches can support their weight and which provide the best jumping points. Squirrel nutrition and diet. The nutritional needs of squirrels are complex and vary with season, reproductive status, and individual condition. Understanding what squirrels eat and why reveals the challenges these animals face in meeting their dietary requirements throughout the year. Nuts are the food most associated with squirrels, and for good reason. Nuts provide dense packages of energy in the form of fats and proteins. A single large nut might provide 10% of a squirrel's daily caloric needs, making them efficient foods worth the effort to cache and protect. Different nut species provide different nutritional profiles. Walnuts are high in omega-3 fatty acids, acorns provide carbohydrates and tannins, hickory nuts offer high fat content, and pecans balance fats and proteins. However, squirrels can't live on nuts alone. They need a diverse diet to obtain all necessary nutrients. In spring, when few nuts remain from the previous year's caches, squirrels eat tree buds, flowers, and emerging leaves. These foods provide vitamin C and other micronutrients lacking in nuts. Tree buds are particularly nutritious, containing concentrated nutrients the tree has stored to support rapid spring growth. Fungi are an important but often overlooked part of squirrel diets. Squirrels eat both above-ground mushrooms and underground truffles. Fungi provide protein, B vitamins, and beneficial compounds not found in plant foods. Some squirrels will cache mushrooms, hanging them in tree branches to dry before storing them, creating preserved food supplies that won't rot. This behavior demonstrates sophisticated food processing beyond simple collection. The protein requirements of squirrels spike during certain life stages. Pregnant and nursing females need enormous amounts of protein to support fetal development and milk production. These females actively seek out protein-rich foods, including insects, bird eggs, nestling birds, and even small snakes or carrion when available. Male squirrels during breeding season also increase protein consumption to support the energetic demands of mate competition. Squirrels obtain calcium from various sources, essential for bone development and, in females, for producing milk. They chew on bones they find, including discarded antlers. They eat the shells of bird eggs rather than just the contents. Some squirrels have even been observed eating concrete or mortar, likely seeking the calcium these materials contain. Urban squirrels sometimes gnaw on cuttlebone provided for pet birds when they can access it. Water needs vary seasonally and with diet. Squirrels eating fresh plant materials and fruits obtain much of their water from food. During winter, when diet consists mainly of dry nuts, water becomes more critical. Squirrels eat snow and ice when liquid water isn't available, though this comes at an energy cost as they must warm the snow to body temperature. In summer, squirrels drink from streams, ponds, bird baths, and even lick dew from leaves. The tannins in acorns present both a challenge and an opportunity for squirrels. Tannins are bitter compounds that can interfere with protein digestion and are mildly toxic in large quantities. However, squirrels have evolved multiple strategies to deal with tannins. They preferentially eat white oak acorns, which are lower in tannins, immediately, while caching red oak acorns, which are higher in tannins but store better. They also selectively eat certain parts of acorns while discarding the most tannin-rich portions. Seasonal changes in food availability drive behavioral changes. In autumn, when nuts are abundant, squirrels enter hyperphagia and may consume 150% of their maintenance caloric needs, building fat reserves. In winter, when food is scarce and energy demands for thermoregulation are high, they may operate at a caloric deficit, losing weight gradually throughout the cold season. By spring, many squirrels are thin and desperate for food, making this the hungriest time of year. Squirrels practice what ecologists call optimal foraging, making decisions that maximize energy gain relative to time and effort spent. If a food patch provides diminishing returns, with the best items already eaten, squirrels will move to a new area rather than exhaustively searching the depleted patch. This behavior matches mathematical models of optimal foraging that predict when animals should leave one feeding area for another. The digestive system of squirrels is adapted to their varied diet. Their cecum, a pouch where the small intestine meets the large intestine, harbors beneficial bacteria that help digest plant materials. Like many herbivorous and omnivorous mammals, squirrels practice coprophagy, eating some of their own feces to recover nutrients, particularly B vitamins, produced by their gut bacteria. This behavior, while seeming strange to humans, is an efficient way to extract maximum nutrition from food. Squirrel learning and memory. The cognitive abilities of squirrels, particularly their learning and memory, are among the most studied aspects of squirrel biology. These studies reveal mental capacities that challenge our assumptions about animal intelligence. Spatial memory in squirrels is exceptional by any standard. In one classic study, squirrels were able to remember the locations of over 150 individual cache sites over a period of months. When tested in controlled conditions, squirrels could remember not just where they had cached food but what type of food they had cached where. This suggests they formed detailed mental maps of their territories with multiple types of information attached to each location. The method squirrels use to remember cache locations involves multiple memory systems working together. They use what scientists call spatial memory, encoding the location of caches relative to landmarks and geometric relationships between objects. They also use episodic-like memory, recalling specific caching events including what they buried, where, and approximately when. This combination of memory types allows them to efficiently relocate their caches even after months. Learning ability in squirrels is demonstrated through their interactions with novel problems. When researchers present squirrels with puzzle boxes requiring multiple steps to access food, squirrels learn the solution through trial and error, but they also show sudden insight moments where they seem to understand the problem structure and solve it efficiently. Once learned, these solutions are remembered for years, even if the squirrel doesn't encounter that specific puzzle again during that time. Social learning occurs in squirrel populations, with younger or less experienced individuals observing and copying the behaviors of others. This is how new food types or new methods of accessing food spread through squirrel populations. If one squirrel in a park learns to open a particular type of bird feeder, other squirrels may learn by watching, leading to a local tradition of feeder rating techniques specific to that population. Squirrels demonstrate what psychologists call response inhibition, the ability to suppress an automatic behavior in favor of a more appropriate one. In tests where squirrels must take a longer route to reach visible food rather than trying to go directly through a clear barrier, many squirrels quickly learn to inhibit their impulse to go straight and instead take the necessary detour. This cognitive flexibility is considered a marker of advanced intelligence. Tool use, while rare, has been documented in some squirrel populations. Individual squirrels have been observed using sticks to extract insects from crevices, using leaves as plates or napkins while eating, and manipulating objects to gain access to food. While these behaviors aren't as sophisticated as tool use in primates or corvids, they demonstrate behavioral flexibility and problem-solving ability. Memory consolidation in squirrels appears to follow similar principles to other mammals. Information moves from short-term to long-term memory through processes that likely occur during sleep. Squirrels spend significant time in REM sleep, the sleep stage associated with memory consolidation in other species. The importance of particular memories, likely related to their survival value, seems to influence how strongly they're encoded and retained. Squirrels show evidence of what's called quantity discrimination, the ability to distinguish between different amounts. In experiments where squirrels can choose between containers with different numbers of nuts visible, they consistently choose the container with more nuts, even distinguishing between quantities like 8 versus 10. This ability helps them make foraging decisions, choosing to visit locations likely to have more food. Individual variation in learning ability and memory has been documented within squirrel populations. Some individuals are faster learners, better at solving puzzles, or have more accurate spatial memory than others. These individual differences might be partly genetic, but experience and early development also play roles. Squirrels that grow up in complex, enriched environments tend to show better problem-solving abilities than those from simpler environments. The question of whether squirrels have conscious awareness or experience emotions remains debated among scientists. However, their behavior suggests they experience states that resemble what we might call frustration, satisfaction, fear, and possibly even play. Young squirrels engaging in games that have no immediate survival value, adult squirrels showing individual preferences for certain foods beyond nutritional value, and the complex decision-making they demonstrate all hint at inner mental experiences, though we may never know exactly what being a squirrel feels like. Winter survival strategies. Winter presents the ultimate survival challenge for squirrels in temperate and cold regions. The strategies they employ to survive months of cold weather and food scarcity are marvels of adaptation, both physiological and behavioral. The preparation for winter begins in late summer, well before the first frost. Changes in day length trigger hormonal shifts that alter squirrel behavior and physiology. Appetite increases dramatically, driving the hyperphagia we've discussed. But metabolism also changes, with the body becoming more efficient at converting food to fat and storing that fat in optimal locations for winter insulation and energy reserves. Fat deposition in autumn follows specific patterns. Squirrels don't just get generally fatter, they deposit fat strategically. Subcutaneous fat, the layer just beneath the skin, provides insulation. Visceral fat, stored around internal organs, provides both insulation and an energy reserve that's quickly accessible. By the start of winter, a well-prepared squirrel might be 25 to 50% heavier than in summer, with much of that additional weight being stored fat. Behavioral changes complement physiological preparation. Squirrels intensify their caching behavior as autumn progresses, sometimes working frantically to cache as many nuts as possible before winter arrives. They also make improvements to their drays or seek out better nest sites, such as tree cavities that offer superior insulation. Multiple nests provide options if one becomes compromised. The winter coat grows in during autumn, transforming the squirrel's appearance. The new fur is not just thicker but structurally different from summer fur. The hairs are longer, and the underfur becomes dense and fluffy, trapping air for insulation. Guard hairs become thicker and provide a water-resistant outer layer. In some squirrel species, winter coat coloration differs from summer, becoming grayer or darker for better heat absorption in weak winter sunlight. As winter arrives and temperatures drop, squirrels adjust their activity patterns. On the coldest days, they may not emerge from their nests at all, conserving energy and relying on stored body fat. On milder days, they venture out to retrieve cached nuts or search for other food sources. This adaptive flexibility allows them to balance the need for food against the energy cost and risk of cold exposure. Huddling behavior becomes important during extreme cold. In species where winter huddling occurs, multiple squirrels will share a nest cavity, pressing together to share body heat. The squirrels on the inside of the huddle stay warmest, while those on the outside get colder, but individuals rotate positions so everyone gets time in the warm center. This cooperative behavior significantly reduces energy expenditure and increases survival rates. Thermoregulation in winter involves multiple strategies. Squirrels can reduce blood flow to their extremities, conserving heat in their body core while allowing their feet and tail to cool. However, if their feet get too cold, they lose dexterity and grip strength, so they must balance heat conservation with maintaining function. The tail can be wrapped around the body like a blanket, providing an extra layer of insulation while sleeping. The energy budget of a winter squirrel is tight. A squirrel must balance energy intake from cached nuts and any food found while foraging against energy expenditure for thermoregulation, movement, and basic metabolism. On the coldest days, it might take more energy to forage than the food found would provide, making it better to stay in the nest and live off fat reserves. Squirrels that enter winter without adequate fat stores or sufficient cached food face high mortality risk. Snow presents both challenges and opportunities. Deep snow makes ground foraging difficult but actually provides insulation, creating an under-snow environment that's warmer than the air above. Some squirrels create tunnels in snow to access cached nuts or to move between trees without being exposed to wind and cold. The snow also provides water during periods when liquid water is frozen. The metabolic rate of squirrels during winter drops below summer levels, though not to the extent seen in true hibernators. This metabolic suppression helps conserve energy but means squirrels are less active and responsive in winter. Their body temperature during sleep may drop several degrees below normal, edging toward torpor but not reaching the deep hibernation of ground squirrels and marmots. Winter mortality is highest among juvenile squirrels, especially those born late in the previous summer who entered winter smaller and less experienced than older individuals. Adult squirrels with established territories and multiple seasons of experience have much better survival rates. The harshest winters can cause significant mortality even in adult populations, acting as a natural population control and potentially selecting for traits that improve winter survival. Squirrel evolution and history. The evolutionary history of squirrels stretches back millions of years, revealing how these animals came to be such successful and diverse group of mammals. Fossils and genetic studies provide glimpses into this ancient story. The earliest squirrel-like rodents appeared in the late Eocene epoch, around 36 million years ago. These ancient ancestors were already showing the body plan that would characterize squirrels: relatively large eyes, long bodies, and adaptations for climbing. Fossils from this period are rare, but those that exist show animals recognizable as squirrel relatives, though smaller and more primitive than modern forms. The family Sciuridae, which includes all modern squirrels, split from other rodent families during the Oligocene epoch, approximately 30 million years ago. During this time, forests were expanding across much of the northern hemisphere, creating ideal habitat for early squirrels. These forests provided abundant nuts and seeds, driving the evolution of specialized teeth and behavior for exploiting these resources. By the Miocene epoch, around 15 million years ago, squirrels had diversified into multiple lineages resembling modern forms. Flying squirrels, ground squirrels, and tree squirrels had already diverged, each group adapting to different ecological niches. Fossil sites from this period show remarkable diversity, suggesting squirrels were already successful and widespread across North America, Europe, and Asia. The patagium of flying squirrels evolved independently at least twice in mammals and represents a remarkable case of convergent evolution. The membrane stretching between limbs allowed these squirrels to exploit three-dimensional space in forests, gliding from tree to tree rather than descending and climbing. Fossils of flying squirrels from the Miocene show these animals had already developed fully functional gliding membranes millions of years ago. Ice ages during the Pleistocene epoch, beginning about 2.6 million years ago, had profound effects on squirrel populations. As glaciers advanced and retreated, squirrel ranges shifted. Populations were separated into isolated refugia, groups that became genetically distinct from each other. When glaciers retreated, these populations expanded again, sometimes meeting and interbreeding, other times remaining separate species. Modern genetic diversity in squirrels reflects these Ice Age population dynamics. The migration of squirrels across continents occurred multiple times throughout their history. Squirrels crossed land bridges between continents when these existed, spreading from Asia to North America across Beringia, and from Asia to Europe. Africa was colonized by squirrels later, and South America was reached only recently in geological time, within the last few million years as the Panamanian land bridge formed. The evolution of food caching behavior was a key innovation in squirrel evolution. This behavior allowed squirrels to survive in temperate regions with seasonal food scarcity. The cognitive abilities required for efficient caching, particularly spatial memory and the ability to find caches months later, drove selection for larger brains and enhanced mental capacities. Squirrels have relatively large brains for rodents, likely partly due to these demands. Coat color evolution in squirrels reflects both adaptation to local environments and random genetic drift. Black squirrels, which are actually melanistic color variants of gray squirrels, may have advantages in colder climates as dark colors absorb solar radiation more efficiently. Red coloration in some species might provide camouflage against tree bark or autumn leaves. White or pale squirrels occasionally occur as color morphs in various species. The relationship between squirrels and trees represents a coevolutionary dynamic spanning millions of years. Trees produce nuts and seeds that squirrels eat and cache, and squirrels serve as dispersal agents for trees. Some trees have evolved nuts too large for small rodents to handle efficiently, but perfect for squirrels. The tannins in acorns may have evolved partly as a defense against seed predators, and squirrels evolved physiological and behavioral strategies to handle tannins. Recent evolution continues to shape squirrel populations. Urban squirrels show measurable evolutionary changes compared to their rural ancestors, including behavioral changes and physiological adaptations to city life. These changes are occurring on timescales of decades to a few centuries, rapid evolution driven by the strong selective pressures of urban environments. Squirrels adapting to human-modified landscapes provide real-time examples of evolution in action. Squirrel territoriality and space use. Understanding how squirrels use space and defend territories reveals the complex social organization underlying what often appears to be solitary behavior. Territory is fundamental to squirrel survival, determining access to food, shelter, and mates. A squirrel's territory is not a fixed boundary, but rather a core area where the squirrel spends most of its time, surrounded by a larger home range that overlaps with neighbors' territories. The core area contains the squirrel's primary nest sites and most reliable food sources. This is the area most vigorously defended against intruders. The outer home range is used for foraging but may be shared with neighbors, particularly during times of food abundance. Territory size varies enormously depending on species, habitat quality, and season. A gray squirrel in a productive forest might maintain a territory of 2 to 8 acres. In urban parks where food is abundant and concentrated, territories might shrink to half an acre or less. Ground squirrels in arid regions might range over much larger areas, seeking widely scattered food sources. Flying squirrels, which can glide long distances, often have territories of 10 acres or more. Males and females use space differently. Male territories are generally larger than female territories and may overlap with the territories of multiple females, especially during breeding season. Males are more interested in access to mates than in defending every food source, so they tolerate more overlap. Females, particularly when raising young, are more aggressive in defending their core territories, as they need exclusive access to sufficient food to support lactation. Territorial boundaries are marked through scent and behavior. Squirrels deposit scent by rubbing their cheeks and bodies on branches, by urinating at specific locations, and through glandular secretions. These scent marks fade over time and must be refreshed regularly. A squirrel can tell by sniffing a scent mark how recently the territory owner passed by and may take this information into account when deciding whether to enter another's territory. Visual displays also communicate territorial ownership. A resident squirrel seeing an intruder will often perform aggressive displays, rapid tail flicking, chattering vocalizations, and sometimes direct charges toward the intruder. Most territorial disputes are resolved through these displays without physical contact. The intruder, recognizing it's at a disadvantage in the resident's territory, usually retreats. However, if the intruder doesn't leave or if both squirrels claim the same territory, fighting may occur. Physical fights between squirrels can be intense. Squirrels grapple with their front paws, bite, and chase each other through the trees at high speed. These fights rarely result in serious injuries because one combatant usually breaks off and flees once a hierarchy is established. However, bites do occur, and these wounds can become infected. Injuries to tails are common, with many adult squirrels showing scars or partially missing tails from past conflicts. Territorial boundaries can shift over time. If a territory owner dies or moves, neighbors may expand their territories into the newly available space. Young squirrels reaching independence must establish their own territories, either finding unoccupied areas or displacing weaker residents. This dynamic means the territorial map of a squirrel population is constantly shifting, with borders renegotiated through ongoing interactions. Seasonal changes affect territoriality. During autumn, when caching behavior is intense, squirrels become more aggressive in defending their territories, as intruders might steal cache sites or rob existing caches. In winter, territoriality relaxes somewhat as activity levels decrease. During spring breeding season, male territories expand dramatically as they range widely seeking receptive females, and territorial disputes among males increase in frequency and intensity. Some areas within a squirrel population's range serve as neutral zones where territoriality is relaxed. Rich food sources like concentrations of nut trees, bird feeders, or fruiting shrubs might attract multiple squirrels who tolerate each other's presence while feeding, though dominance hierarchies still influence who feeds first and who waits. These temporary aggregations at food sources don't indicate true social grouping, but rather mutual tolerance driven by abundant resources. The cognitive map a squirrel maintains of its territory is remarkably detailed. Squirrels know not just the locations of their caches but also which trees produce the most nuts, where the best nest sites are located, which routes through the trees are safest and fastest, and where territorial boundaries with neighbors lie. This mental map is built through constant exploration and updated continuously as conditions change. The complexity of this spatial knowledge is one reason squirrels have relatively large brains for their body size. Squirrel vocalizations in depth. The vocal communication system of squirrels is far more complex than the simple chattering most people hear. Each call type conveys specific information, and the context in which calls are given adds additional layers of meaning. The kook call we've mentioned is actually a series of distinct vocalizations that vary in rhythm, intensity, and pitch. A slow series of cucks with long pauses indicates low-level alarm or annoyance. As threat level increases, the rate of cucks increases and pauses shorten, until in extreme alarm situations, cucks blend into almost continuous chattering. Squirrels hearing these calls can assess threat level from the calling pattern even without seeing the threat themselves. The quah call is longer and more variable in structure than cucks. It's typically used when threats are immediate and severe. Interestingly, squirrels don't just give quah calls randomly, they direct them toward the threat. A squirrel giving quah calls at a snake will face the snake while calling, and the acoustic properties of the call may vary depending on whether the threat is a snake, a mammalian predator, or a human. Mobbing calls represent another vocal category. When squirrels discover a predator that's not immediately threatening, such as a perched hawk or a snake that's not actively hunting, they may engage in mobbing behavior. They approach the predator while giving specific calls that attract other squirrels. The group then harasses the predator with calls and aggressive displays until it leaves the area. This behavior reduces predation risk by making predators aware they've been detected and by teaching young squirrels to recognize dangerous species. Contact calls are quieter vocalizations used for maintaining awareness of nearby squirrels. Mother squirrels and their young use soft chirps and clicks to stay in touch when foraging separately. These calls don't carry far and aren't typically heard by human observers, but they serve important social functions, allowing squirrels to coordinate activities and maintain group cohesion when beneficial. Mating calls are quite different from alarm calls. During breeding season, males produce distinctive calls, sometimes described as buzzing or muffled barking sounds. These calls likely advertise male presence and quality to females while also warning other males to stay away. Females approaching estrus sometimes produce their own calls, softer and higher-pitched, that attract males from surrounding territories. Infant squirrels produce specific distress calls when separated from their mothers, cold, or hungry. These high-pitched squeaks are acoustically structured to be attention-grabbing and emotionally compelling to mother squirrels. Mothers respond rapidly to these calls, returning to the nest to attend to their young. As babies mature, these calls change in structure, becoming more adult-like as their vocal apparatus develops. Aggressive calls accompany territorial disputes and fights. These growls, screams, and intense chattering serve to intimidate opponents. The calls may escalate in intensity as an aggressive encounter becomes more serious, possibly serving as final warnings before physical combat begins. Some researchers believe the pitch and intensity of aggressive calls may convey information about the caller's size and fighting ability, allowing opponents to assess each other before deciding whether to fight or retreat. Individual variation exists in squirrel vocalizations. While the basic structure of calls is similar across individuals, subtle differences allow squirrels to recognize each other by voice. This individual recognition helps maintain social relationships and territorial boundaries. A squirrel might respond differently to the calls of a familiar neighbor than to the calls of a stranger, showing that they're not just responding to call type, but also to caller identity. Learning plays a role in vocalization development. While baby squirrels are born with the ability to produce basic calls, the refinement and appropriate use of these calls improves with experience. Young squirrels go through a period where their calls are less precisely structured and sometimes given in inappropriate contexts. Through trial, error, and possibly by observing adults, they learn when and how to call effectively. The acoustic environment influences calling behavior. In noisy urban environments, some squirrel populations have shifted the frequency of their calls higher or lower to avoid overlap with urban noise, particularly traffic sounds. This is a form of cultural adaptation, where populations develop local calling traditions that differ from other populations of the same species in quieter environments. These dialectal differences can emerge within just a few generations in rapidly urbanizing areas. The role of play in squirrel development. Play behavior in young squirrels is not just adorable entertainment for human observers. It serves crucial developmental functions that enhance survival skills and physical capabilities. Understanding play helps us appreciate the complexity of squirrel psychology and development. Play in squirrels begins around 7 to 8 weeks of age, shortly after young squirrels first leave the nest. Initial play is simple: chasing siblings around branches near the nest entrance, gentle wrestling, and touching noses. These early games help young squirrels develop coordination and spatial awareness in a relatively safe environment close to shelter. As young squirrels become more confident, their play becomes more elaborate and physically demanding. Chase games extend farther from the nest, involving rapid runs along branches, jumps between trees, and complex three-dimensional maneuvers. During these chases, young squirrels practice the movements they'll need throughout their lives: sudden direction changes, emergency jumps, and quick scrambles to safety. Wrestling play teaches young squirrels important lessons about physical combat and dominance hierarchies. During these mock battles, young squirrels grapple, bite gently, and push each other. They learn to assess their own strength relative to others, to read body language indicating aggression or submission, and to understand that conflicts have winners and losers. These lessons will prove essential when they must compete for territories and mates as adults. Object play is common in young squirrels. They'll manipulate pine cones, leaves, twigs, and other items they find, carrying them around, burying and digging them up, and sometimes engaging in what looks like keep-away games with siblings. This play helps develop the fine motor skills needed for food handling and caching. It also appears to satisfy curiosity and provide cognitive stimulation. Jumping practice is a distinct form of play visible in young squirrels. They'll repeatedly jump across the same gap between branches, each time testing themselves at slightly greater distances or more challenging angles. This deliberate practice builds muscle strength, improves coordination, and helps young squirrels learn their physical capabilities and limitations. Through countless practice jumps, they develop the judgment needed to make accurate leaps when fleeing predators or foraging. Social play establishes and maintains relationships between siblings. Play partners develop bonds that may influence their later social interactions as adults. Siblings who played together extensively as juveniles sometimes establish neighboring territories and show more tolerance toward each other than toward non-related neighbors. Play may thus serve a social bonding function that has implications for long-term population structure. The play behavior of young squirrels changes as they mature. Very young squirrels play more frequently and with less inhibition than older juveniles. As they approach independence, play becomes less common and more structured, resembling true aggressive encounters more closely. This shift reflects their developing maturity and the increasing seriousness of their social interactions as they prepare to establish independent lives. Play appears to be intrinsically rewarding for squirrels. Young squirrels will choose to play even when other important activities like foraging are available. They show signs of enjoyment during play, including distinctive facial expressions and vocalizations different from those heard in other contexts. The brain chemistry of play in mammals generally involves dopamine and opioid systems associated with pleasure and reward, and squirrels likely experience similar neurochemical rewards from play. Environmental enrichment affects play behavior. Young squirrels growing up in complex, stimulating environments with varied vegetation, topography, and opportunities for exploration engage in more diverse and sophisticated play than those in simpler environments. This early experience may contribute to the development of problem-solving abilities and behavioral flexibility that enhance survival throughout their lives. Even adult squirrels occasionally engage in play-like behaviors, though far less frequently than juveniles. These rare play episodes in adults might serve to maintain physical fitness, provide stress relief, or simply be enjoyable. The persistence of play into adulthood, even if infrequent, suggests it serves functions beyond mere practice for necessary skills, pointing to the possibility of rich emotional lives in these animals. Squirrel interactions with other species. Squirrels don't live in isolation. They exist within complex ecological communities, interacting with countless other species. These interactions range from cooperative to competitive to predatory, each shaping the lives of squirrels in important ways. The relationship between squirrels and corvids, particularly jays and crows, is one of mutual thievery and complex interaction. Jays cache nuts much as squirrels do, and both species rob each other's caches. However, jays have one advantage: they can see squirrels caching from above and note the locations. Squirrels have responded by increasing their use of deceptive caching when jays are present. This ongoing arms race has likely influenced the evolution of intelligence in both groups. Squirrels and woodpeckers share a fascinating relationship centered on tree cavities. Woodpeckers excavate holes in trees for nesting, and squirrels often take over abandoned woodpecker cavities for their own nests. This provides squirrels with high-quality nest sites they couldn't create themselves. In return, squirrels spread fungi spores that may help decompose dead wood, potentially providing woodpeckers with more trees containing the insects they feed on. Competition between squirrels and chipmunks occurs where their ranges overlap. Both are nut-caching rodents with similar diets, and they compete for the same food resources. Generally, tree squirrels dominate at height while chipmunks dominate on the ground, but at intermediate levels, direct competition occurs. Chipmunks are often more efficient foragers on the ground due to their smaller size and lower energy needs, while tree squirrels can access resources in tree crowns that chipmunks cannot reach. Deer and squirrels have an interesting indirect relationship. Deer browsing affects forest structure, determining which plants thrive and which are suppressed. Heavy deer browsing can reduce understory vegetation, potentially making ground foraging more dangerous for squirrels by reducing cover from predators. However, deer also create trails that squirrels sometimes use for ground travel, and deer disturbance may increase the growth of some plants squirrels eat. Squirrels serve as hosts for numerous parasites that have their own ecological relationships. Fleas that live on squirrels may carry diseases that affect other species, including humans. Bot flies lay eggs on squirrels, and their larvae develop under squirrel skin before emerging. Ticks feeding on squirrels can transmit diseases both to squirrels and to other animals, including humans. These parasite relationships connect squirrels to broader disease ecology networks. The interaction between squirrels and ants involves both conflict and inadvertent mutualism. Ants will attack squirrels approaching their nests or trails, and squirrels generally avoid heavy ant concentrations. However, squirrels caching nuts sometimes bury them near ant nests. The ants may discover and consume some nuts, but they also aerate soil and deter other seed predators, potentially increasing germination success for seeds the squirrels don't retrieve. Neither species intends this outcome, but both may benefit. Birds of prey and squirrels exist in a classic predator-prey relationship, but it's more complex than simple hunting. Squirrels learn to recognize individual hawks and respond with different levels of alarm depending on the specific predator. Some hawks hunt squirrels frequently and effectively, while others rarely catch squirrels. Squirrels appear to recognize these differences and adjust their responses accordingly, showing more alarm and taking fewer risks when dangerous hawks are near. Squirrels occasionally prey on bird eggs and nestlings, making them predators from the perspective of songbirds. This predation can significantly impact bird populations, particularly in urban parks where squirrel densities are high. Birds have evolved various strategies to defend against squirrels, including nest placement, timing of nesting, and mobbing behavior. Some bird species have declined in areas with high squirrel populations due to this nest predation. Fungi and squirrels have co-evolved in complex ways. Many fungi depend partly on squirrels for spore dispersal. When squirrels eat mushrooms and truffles, spores pass through their digestive systems and are deposited across the landscape in squirrel feces. These fungi, in turn, form mycorrhizal associations with trees, helping trees absorb water and nutrients. Thus, squirrels indirectly support tree health and forest productivity through their role in fungal dispersal. The presence of squirrels affects the behavior of other animals in their habitat. Small rodents like mice and voles may avoid areas where squirrels are common, either because squirrels compete for food or because the predators that hunt squirrels also pose danger to smaller rodents. Conversely, some small animals may benefit from squirrel alarm calls, gaining warning of approaching predators even though the calls aren't directed at them. These indirect effects ripple through ecological communities in complex ways. Squirrel genetics and inheritance. The genetic makeup of squirrels determines not just their physical appearance but also influences behavior, physiology, and survival. Modern genetic research is revealing the complex hereditary patterns that shape squirrel populations. Coat color in squirrels is controlled by several genes interacting in complex ways. The basic gray color of gray squirrels is dominant, but mutations in melanin-producing genes can produce black squirrels, which are actually melanistic gray squirrels. This melanism is caused by a deletion in the MC1R gene. Black squirrels aren't a separate species but a colormorph, and black and gray squirrels can interbreed, producing offspring of either color depending on genetic inheritance patterns. Albino squirrels lack pigmentation entirely due to mutations that prevent melanin production. True albinos have pink eyes and pure white fur. They're rare because the genes causing albinism are recessive, meaning a squirrel must inherit the mutation from both parents to be albino. Additionally, albino squirrels face survival disadvantages. They're more visible to predators, more susceptible to sun damage, and may have vision problems due to lack of pigment in their eyes. White squirrels are different from albinos. Some white squirrel populations have a different genetic basis for their coloration, producing white fur but normal eye pigmentation. These squirrels often have black eyes and may have patches of darker fur. Several towns in North America have populations of white squirrels that are locally celebrated and even protected by ordinances. These populations persist due to genetic inheritance of the white coat trait. Body size in squirrels has a heritable component, with larger parents tending to produce larger offspring. However, environmental factors during development also significantly influence adult size. Well-fed juveniles with access to high-quality food grow larger than genetically similar juveniles raised in poor conditions. This interaction between genes and environment, called phenotypic plasticity, allows squirrels to adjust their growth to match local conditions. Behavioral traits also show genetic influences, though behavior is generally more influenced by learning and environment than physical traits. Boldness, the willingness to approach novel objects or take risks, shows individual variation that's partly heritable. Some squirrels are naturally more cautious while others are more exploratory. In urban environments, bolder squirrels may have advantages, leading to selection for boldness in city populations over generations. Genetic diversity within squirrel populations is crucial for long-term survival. Populations with low genetic diversity are more vulnerable to diseases, environmental changes, and inbreeding depression. Isolated populations, such as squirrels on islands or in fragmented urban parks, can lose genetic diversity over time. Conservation efforts for rare squirrel species often focus on maintaining genetic diversity through protecting large, connected populations. Mutations continuously introduce new genetic variation into squirrel populations. Most mutations are neutral or slightly harmful, but occasionally a mutation provides an advantage. The mutation conferring resistance to certain tree toxins, for example, could allow squirrels to exploit food sources unavailable to other squirrels. Over time, beneficial mutations increase in frequency through natural selection. The genetic basis of disease resistance varies among individuals. Some squirrels have genetic variants that provide better immune responses to parasites or pathogens. These individuals are more likely to survive disease outbreaks and pass their resistance genes to offspring. This genetic variation in disease resistance is why populations don't get entirely wiped out by epidemics. Some individuals almost always have the genetic tools to survive. Genetic studies of squirrel populations reveal patterns of historical migration and isolation. By comparing DNA from squirrels in different regions, scientists can reconstruct how populations spread, when they separated, and how much gene flow occurs between regions. These studies show that some apparent squirrel species are actually groups of closely related species that diverged relatively recently, while other populations showing little outward difference are genetically quite distinct. Epigenetics, the study of how environmental factors influence gene expression without changing DNA sequences, is an emerging field in squirrel biology. Stressful early life experiences can alter gene expression patterns in ways that persist into adulthood, affecting behavior and physiology. A squirrel that experiences food scarcity as a juvenile might show different metabolic regulation as an adult compared to a well-fed juvenile, even if they're genetically identical. These epigenetic effects may even be passed to offspring, allowing parental environmental experiences to influence the next generation. Squirrels and forest ecology. Squirrels are not just residents of forests, they're active participants in shaping forest ecosystems. Their activities influence tree populations, nutrient cycling, and the broader ecological community in ways that cascade through the entire system. The tree planting service squirrels provide is difficult to overstate. Estimates suggest that squirrels plant more trees than any other animal or natural process except human forestation efforts. By caching thousands of nuts and failing to retrieve about 20% of them, each squirrel plants hundreds of seeds annually in conditions ideal for germination, buried at the right depth, in soil disturbed by digging, often in locations away from the parent tree where competition is less intense. Seed selection by squirrels influences which tree species dominate forests. Squirrels show preferences for certain nut species over others, and they cache preferred species in different locations or patterns than less preferred species. These preferences can advantage certain tree species in the competition for space and resources. Oak species that produce nuts preferred by squirrels for caching might colonize new areas more successfully than oak species whose nuts are more often eaten immediately. The timing of tree reproduction has been shaped partly by squirrel predation pressure. Massed years, when trees synchronize to produce enormous crops of nuts all at once, are thought to be an evolved response to seed predators like squirrels. By overwhelming seed predators with more nuts than they can possibly eat or cache, trees ensure that some seeds survive. Squirrels, in turn, have evolved to increase caching behavior during massed years, storing the windfall for leaner years ahead. Squirrel gnawing affects tree health and structure. When squirrels strip bark to eat the cambium layer beneath, they wound trees and create entry points for insects and fungi. In extreme cases, girdling a branch or trunk can kill the tissue beyond the wound. However, moderate gnawing may stimulate tree defenses and has minimal impact on overall tree health. Some trees have evolved thicker bark or chemical defenses specifically in response to squirrel gnawing. The creation of drays contributes organic matter to forests. When drays decay or fall apart, the nest material adds nutrients to the soil below. The area around regularly used drays shows elevated nutrient levels compared to surrounding forest. Over years and decades, this nutrient deposition can affect plant growth patterns, creating microhabitats with slightly different vegetation. Squirrel digging, both for caching nuts and retrieving them, disturbs soil and affects decomposition rates. This disturbance mixes organic matter into mineral soil, speeds decomposition, and creates conditions suitable for seed germination. The thousands of small digging events by squirrels across a forest have cumulative effects on soil structure and nutrient cycling, though these effects are less dramatic than those of larger digging animals like wild pigs. The food web connections of squirrels link trees to predators. Squirrels convert plant materials into animal protein, making the energy stored in nuts available to carnivorous animals that can't eat nuts directly. In forests, squirrels often represent the most abundant mid-sized prey, supporting populations of hawks, owls, foxes, and other predators. These predators, in turn, regulate squirrel populations and influence squirrel behavior through the ever-present threat of predation. Squirrels influence bird populations in complex ways. By consuming bird eggs and nestlings, squirrels negatively affect some bird species. However, squirrels also compete with jays and other nut-eating birds, and changes in squirrel populations affect bird populations. Additionally, abandoned squirrel drays provide nesting sites for some bird species. The net effect of squirrels on bird communities varies by location and species composition. Forest management practices affect squirrel populations, and these effects feed back into forest ecology. Selective logging that removes the largest, oldest trees eliminates prime squirrel habitat, as these trees often have cavities for nesting and produce the most nuts. Clear cutting destroys squirrel habitat entirely. However, some forest management practices, like selective thinning that increases nut production in remaining trees, can benefit squirrels. Understanding these interactions helps foresters manage for both timber production and wildlife habitat. Climate change is altering the relationship between squirrels and forests. Warming temperatures allow squirrels to expand their ranges northward and to higher elevations. Changes in precipitation patterns affect nut production, potentially creating more variable food supplies. Warmer winters may benefit squirrels by reducing overwinter mortality, but they also allow parasites and diseases to survive that previously died during cold winters. How squirrels and forest ecosystems adapt to these changes will shape future forests in ways we're only beginning to understand. Squirrel locomotion mechanics. The way squirrels move through their three-dimensional arboreal world is a biomechanical marvel. Every aspect of their locomotion, from the structure of their limbs to the coordination of their movements, is optimized for life in the trees. When a squirrel runs along a horizontal branch, it uses a bounding gait similar to a rabbit's hop. The hind legs push off together, propelling the body forward, while the front legs land together to catch the body's weight. This gait is efficient for rapid movement and allows the squirrel to accelerate quickly when needed. At top speed on the ground, squirrels can reach 20 miles per hour, impressive for an animal weighing less than a pound. Vertical climbing employs a different mechanical strategy. Squirrels climb using alternating diagonal limb movements, right front with left hind, then left front with right hind. This pattern maintains 3 points of contact with the tree at all times, providing stability. The hind limbs provide most of the propulsive force, pushing the squirrel upward, while the front limbs help stabilize and steer. Descending headfirst requires the specialized ankle rotation we've discussed, but also involves specific movement patterns. Squirrels descend in a controlled slide, using their claws as brakes and their body position to control descent speed. They can pause instantly at any point by flexing their ankles and increasing claw pressure. This control allows them to descend safely even on smooth bark where grip is limited. The energy efficiency of squirrel locomotion varies with substrate and speed. Moving along thick, stable branches is energetically cheap. Thin, flexible branches require more energy as the squirrel must constantly adjust balance. High-speed chases are energetically expensive, burning calories rapidly. Squirrels balance speed against energy expenditure, moving quickly only when necessary for escaping danger or competing for resources. Jumping biomechanics involve precise timing and force generation. In the split second before launch, a squirrel crouches, loading the spring-like tendons in its legs. The jump itself involves explosive extension of the hind legs, generating force that propels the squirrel forward. During the jump, the tail actively controls orientation, making continuous micro-adjustments to keep the squirrel on target. Landing mechanics are equally sophisticated. Just before impact, squirrels extend their front legs to contact the landing surface first. These legs absorb initial impact while claws grip the substrate. A fraction of a second later, the hind legs land, and the squirrel's entire body flexes to dissipate remaining energy. The spine, ribs, and limbs all compress slightly, turning what would be a devastating impact into a manageable landing. The gait transitions of squirrels happen seamlessly as they move between different surfaces. A squirrel might run along the ground, bound up a tree trunk, scamper along a branch, leap to another tree, and land running without any apparent pause or adjustment period. These smooth transitions require sophisticated neural control and demonstrate the flexibility of the squirrel's motor system. Squirrels adjust their movements based on substrate properties. On thick, rough bark, they use powerful grip with all claws engaged. On smooth bark or artificial surfaces like metal poles, they adjust their technique, sometimes spread-eagling their bodies to increase contact area and friction. On narrow branches or wires, they move more slowly and carefully, using their tail as a counterbalance. The development of locomotor skills in young squirrels follows a predictable but individually variable timeline. Early movements are clumsy and uncoordinated. Falls are common as juveniles misjudge distances or lose their grip. But neural pathways are rapidly being established, muscle strength is building, and proprioceptive abilities are sharpening. Within weeks, movements become fluid and confident. By 3 months, young squirrels move with nearly adult-level competence. Injury or disability can affect squirrel locomotion, but squirrels show remarkable adaptability. Individuals with missing limbs, damaged tails, or other injuries often survive and even thrive by developing compensatory movement strategies. A squirrel with a damaged tail might use different balancing techniques or avoid the most acrobatic movements. These adaptations demonstrate the flexibility of the nervous system and the resilience of these animals. The squirrel's brain and nervous system. The brain of a squirrel, while small in absolute terms, is relatively large for a rodent and contains the neural machinery necessary for their complex behaviors and cognitive abilities. Understanding their nervous system reveals how squirrels process information and coordinate their actions. The squirrel brain weighs only a few grams, but it contains billions of neurons connected by trillions of synapses. The cerebral cortex, the outer layer of the brain responsible for higher cognitive functions, is relatively developed in squirrels compared to many other rodents. This cortical development correlates with their sophisticated spatial memory, problem-solving abilities, and behavioral flexibility. The hippocampus, a brain region crucial for spatial memory, is proportionally larger in food-caching squirrels than in non-caching rodents. Research has shown that during autumn caching season, the hippocampus actually grows, adding new neurons to handle the increased memory load of thousands of cache locations. This seasonal neuroplasticity, the ability of the brain to change its structure, is a remarkable adaptation to the demands of caching behavior. The cerebellum, located at the back of the brain, coordinates movement and balance. In squirrels, this structure is relatively large, reflecting the complex motor demands of arboreal life. The cerebellum receives input from proprioceptors throughout the body and from the vestibular system, integrates this information with motor commands from the cortex, and produces the smooth, coordinated movements we observe in squirrels. Sensory processing in the squirrel brain involves multiple specialized regions. The visual cortex processes information from the eyes, creating detailed representations of the squirrel's surroundings. The auditory cortex analyzes sounds, including vocalizations from other squirrels and sounds that might indicate predators. The somatosensory cortex processes touch information from the body surface, particularly from the sensitive whiskers and paw pads. The speed of neural processing in squirrels must be extremely fast to support their rapid movements. When a squirrel leaps between trees, sensory information about branch position, distance, and movement must be processed, compared with internal predictions, and converted into motor commands in a fraction of a second. This rapid processing requires efficient neural circuits and fast conduction velocities in nerve fibers. Neural plasticity extends beyond seasonal changes in the hippocampus. Throughout their lives, squirrels can modify neural connections in response to experience. Learning new skills, adapting to new environments, or recovering from injuries all involve changes in brain structure and function. Young squirrels show particularly high plasticity, allowing rapid learning during their critical early developmental period. The autonomic nervous system in squirrels regulates unconscious bodily functions like heart rate, digestion, and thermoregulation. This system must rapidly adjust to the changing demands squirrels face. When a predator appears, the sympathetic nervous system activates the fight-or-flight response. Heart rate increases, blood flow shifts to muscles, and digestion slows. When the threat passes, the parasympathetic system restores normal function. Hormones interact with the nervous system to influence behavior and physiology. Stress hormones like cortisol affect how squirrels respond to threats. Sex hormones drive reproductive behaviors during breeding season. Seasonal changes in day length trigger hormonal cascades that prepare squirrels for winter or initiate breeding. These hormonal influences on the nervous system create the seasonal behavioral changes we observe in squirrel populations. The peripheral nervous system extends throughout the squirrel's body, carrying sensory information to the brain and motor commands to muscles. Nerve endings in the skin detect touch, pressure, temperature, and pain. These signals travel along nerve fibers to the spinal cord and brain. Motor neurons carry commands from the brain through the spinal cord to muscles, initiating contractions that produce movement. The question of consciousness in squirrels remains philosophically challenging. We cannot know what subjective experiences squirrels have or whether they possess self-awareness. However, their complex behaviors, problem-solving abilities, emotional responses, and flexible adaptation to novel situations suggest they have rich inner experiences. The neural substrate for consciousness exists in their brains, though the nature of any squirrel consciousness remains mysterious to us. Squirrel parasites and symbionts. Squirrels host a diverse community of organisms living on and inside their bodies. While many of these are parasites that extract resources from squirrels, some relationships may be more complex, and understanding this hidden world reveals another dimension of squirrel ecology. Fleas are among the most common ectoparasites on squirrels. Several flea species specialize on squirrels, spending their entire lives on their hosts. Fleas pierce squirrel skin and feed on blood, potentially transmitting diseases in the process. A single squirrel might harbor dozens of fleas, though the immune system and grooming behavior keep numbers in check. Heavy flea infestations can cause anemia and skin irritation. Ticks attach to squirrels when they brush against vegetation where ticks are waiting. Once attached, ticks feed on blood for several days before dropping off. Ticks can transmit serious diseases including Lyme disease, though squirrels themselves seem relatively resistant to many tick-borne pathogens. However, squirrels serve as amplifying hosts, maintaining tick populations and disease cycles that affect other animals including humans. Mites cause mange in squirrels, a condition that can be severe. Mange mites burrow into skin, causing intense itching and hair loss. Affected squirrels scratch constantly, creating wounds that can become infected. In severe cases, squirrels lose most of their fur, and many don't survive their first winter in this condition. Mange outbreaks can sweep through squirrel populations, though survivors may develop some immunity. Lice are permanent residents on squirrels, completing their entire life cycle on the host. These small insects feed on skin debris and secretions. While less harmful than many parasites, heavy louse infestations can cause discomfort and may transmit other parasites. Squirrels regularly groom themselves and each other partly to control louse numbers. Internal parasites are ubiquitous in wild squirrels. Intestinal worms, including roundworms and tapeworms, inhabit the digestive tract. These parasites absorb nutrients from digested food, effectively stealing resources from the squirrel. Light worm burdens have minimal effect on healthy squirrels, but heavy infections can cause malnutrition, particularly in young or stressed individuals. Protozoans, single-celled parasites, infect various tissues in squirrels. Some species live in the intestines, others in blood cells. Toxoplasmosis, caused by the protozoan Toxoplasma gondii, occasionally infects squirrels, though they're not the primary host for this widespread parasite. These infections typically cause few symptoms in healthy squirrels but can be serious in immunocompromised individuals. Bot fly larvae represent one of the most visible parasitic infections. The adult bot fly lays eggs on squirrels, and the larvae burrow under the skin, creating characteristic bumps called warbles. The larva feeds on tissue and fluids while developing inside the squirrel. Eventually, the mature larva emerges, drops to the ground, and pupates. Despite their horrifying appearance, warbles usually don't significantly harm squirrels. Bacterial infections can occur when skin is broken through wounds, parasites, or environmental trauma. Squirrels possess immune systems capable of fighting bacterial infections, but serious infections can develop, particularly in weakened individuals. Abscesses, infected wounds that fill with pus, sometimes form after bite wounds from fights. These can heal on their own or, in severe cases, become life-threatening. Fungal infections occasionally affect squirrels, particularly skin infections. Ringworm, despite its name actually a fungus, causes patches of hair loss and scaly skin. Respiratory fungal infections are rarer but more serious, potentially causing chronic illness. Squirrels living in damp conditions may be more vulnerable to fungal infections than those in drier environments. The gut microbiome of squirrels, the community of bacteria living in their digestive tract, represents a more ambiguous relationship. While technically parasites, living on resources the squirrel provides, these bacteria also benefit squirrels by helping digest plant materials, producing vitamins, and competing with harmful bacteria. This relationship is likely mutualistic, with both squirrels and their gut bacteria benefiting from the association. Squirrel sensory worlds. To understand how squirrels experience reality, we must consider how their different senses create a composite picture of the world around them. The squirrel's sensory world differs from ours in important ways, highlighting different aspects of the environment we share. The visual world of squirrels emphasizes movement and spatial relationships over color and fine detail. Their visual acuity, while good, doesn't match human vision. However, their motion detection is superior, allowing them to notice the slightest movement of a predator or the sway of a branch. This trade-off makes sense for animals where detecting threats and judging jumping distances matters more than recognizing fine patterns. Color perception in squirrels, as we've mentioned, is dichromatic. They see blues and greens well but struggle to distinguish reds from greens, perceiving both as yellowish. This color vision is still useful, helping them identify ripe fruits, healthy vegetation, and possibly even emotional states in other squirrels, as blood flow changes could affect skin color visible through less furred areas. The olfactory world of squirrels is rich beyond human comprehension. Where we might smell forest, a squirrel smells a complex mixture of individual components. This tree species, that fungus, a cache site from 2 weeks ago, the scent mark of a neighbor from yesterday, the smell of disturbed soil, traces of predators. This olfactory landscape provides constant information about food, danger, and social relationships. Squirrels can detect pheromones that provide social information we cannot perceive. A female approaching estrus releases pheromones that males can detect from considerable distances, allowing males to monitor female reproductive status without visual contact. Stressed squirrels release different pheromones that may signal danger to others, creating chemical alarm signals complementing vocal alarms. The tactile world perceived through whiskers extends squirrel awareness into spaces they cannot see. When moving through dense vegetation at night or entering tree cavities in darkness, whiskers detect obstacles and openings before the body encounters them. This tactile sensory bubble surrounding the squirrel helps them navigate confidently even without visual information. Sound provides another layer of environmental awareness. The rustling of leaves might indicate an approaching predator or another squirrel. The alarm calls of birds signal danger. The crack of breaking branches warns of falling debris. Wind sounds provide information about weather conditions. To a squirrel, the sonic environment is constantly providing data for decision-making. Proprioception creates an internal sensory map of body position and movement. A squirrel doesn't need to look at its paws to know where they are or how they're moving. This internal awareness allows complex movements to be executed while visual attention is directed elsewhere, like watching for predators while running along branches. The vestibular sense of balance provides continuous information about head orientation relative to gravity and about rotational movements. This sense is crucial for maintaining balance on narrow branches and for the aerial righting reflex that allows squirrels to reorient during falls. Damage to the vestibular system would be devastating, making coordinated movement nearly impossible. Temperature sensation helps squirrels regulate their behavior to maintain body temperature. On cold mornings, they can sense when their bodies are losing heat too rapidly and seek shelter or sunlit spots. On hot afternoons, they detect overheating and move to shade or cool surfaces. This thermal awareness operates continuously in the background, influencing countless small decisions. Pain sensation, while unpleasant, provides crucial survival information. Pain from an injury prompts protective behavior, reducing the risk of further damage. The anticipation of pain influences risk assessment, making squirrels cautious in situations where injury is likely. The pain system, like all sensory systems, exists because it enhanced survival in ancestral squirrels, and it continues to serve this protective function. The future of squirrels. Looking forward, the future of squirrels will be shaped by human activities, climate change, and the continuing process of evolution. Understanding the challenges and opportunities squirrels face helps us predict how these adaptable animals might fare in coming decades and centuries. Climate change will likely reshape squirrel distributions across continents. As temperatures warm, squirrels will expand their ranges poleward and to higher elevations, tracking suitable climate conditions. However, this expansion depends on habitat availability. Squirrels cannot simply move north if forests don't extend in that direction, or if human development blocks migration routes. Some squirrel species may benefit from climate change, at least initially. Warmer winters could reduce overwinter mortality, allowing populations to grow. Extended growing seasons might increase food availability in some regions. However, these potential benefits come with risks. Changing precipitation patterns could affect nut production, new parasites and diseases might emerge, and extreme weather events could cause sudden die-offs. Urban environments will continue expanding, creating both challenges and opportunities for squirrels. Adaptable species like gray squirrels will likely thrive in cities, potentially reaching densities higher than natural populations. However, increased urbanization fragments remaining natural habitat, isolating populations and reducing genetic diversity. Urban squirrels and forest squirrels may gradually diverge, becoming genetically and behaviorally distinct. Conservation efforts will be crucial for rare and threatened squirrel species. Habitat protection, particularly preserving old-growth forests and connecting habitat fragments with wildlife corridors, will determine whether specialist species survive. Some species may require active management, including captive breeding and reintroduction programs. The success of these efforts depends on human commitment to biodiversity conservation. Emerging diseases pose ongoing threats to squirrel populations. The introduction of new pathogens, whether through climate change allowing tropical diseases to spread, through international trade, or through spillover from domestic animals, could cause epidemics. However, genetic diversity within squirrel populations provides hope that at least some individuals would survive any disease outbreak, allowing populations to recover. The relationship between humans and squirrels will continue evolving. In some regions, squirrels are beloved wildlife neighbors. In others, they're viewed as pests. Managing this relationship will require balancing human interests with wildlife welfare. Education about squirrel ecology and behavior can foster coexistence, while practical measures like squirrel-proof bird feeders and humane exclusion from buildings can reduce conflicts. Genetic technologies may offer new tools for squirrel conservation. Genetic rescue, introducing individuals from healthy populations to boost diversity in struggling populations, could help maintain viability. Genomic studies could identify populations of conservation priority. However, these technologies raise ethical questions about appropriate interventions in wild populations. The role of squirrels in ecosystems will remain important regardless of human activities. As long as squirrels exist, they'll continue planting trees, dispersing fungi, providing prey for predators, and influencing forest ecology. Their ecological functions are sufficiently important that squirrel extinctions would have cascading effects throughout ecosystems. Research into squirrel biology will undoubtedly reveal new insights. As technology advances, allowing more detailed study of behavior, cognition, and physiology, our understanding will deepen. We may discover unexpected cognitive abilities, complex social dynamics, or novel adaptations. Each discovery will enrich our appreciation of these remarkable animals. The evolutionary future of squirrels remains open. Evolution hasn't stopped. Squirrels are continuing to adapt to changing conditions. Urban squirrels are already showing evolutionary changes. Over longer timescales, selection pressures will shape squirrel bodies, behaviors, and life histories in ways we cannot predict. The squirrels of the future may differ from those of today, but they'll carry forward the legacy of millions of years of adaptation. Closing reflections on squirrels. As we conclude this exploration of squirrels, let us reflect on what we've learned and what these animals represent in the larger tapestry of life on Earth. Squirrels are far more than the familiar park residents we often take for granted. They are sophisticated, intelligent animals with complex lives and important ecological roles. The resilience of squirrels is remarkable. Despite facing predators, parasites, harsh weather, food scarcity, and human interference, squirrel populations persist. This resilience stems from their adaptability, behavioral flexibility allowing them to adjust to new situations, physiological tolerance for varied conditions, and reproductive capacity enabling populations to recover from setbacks. The intelligence we've explored throughout these segments should fundamentally change how we view squirrels. These are not simple creatures operating on instinct alone. They remember thousands of cache locations, solve complex problems, communicate with sophisticated signals, make cost-benefit decisions, and learn from experience. Their cognitive abilities rival those of animals we typically consider more intelligent. The beauty of squirrels exists not just in their physical form but in their movements. Watch a squirrel navigate through tree branches, and you witness poetry in motion, fluid grace, split-second decisions, perfect landings. This beauty is functional, every movement optimized by millions of years of evolution, but it's beauty nonetheless. The interconnectedness of squirrels with their ecosystems reminds us that no species exists in isolation. Squirrels depend on trees for food and shelter. Trees depend on squirrels for seed dispersal. Predators depend on squirrels as prey. Parasites depend on squirrels as hosts. Remove squirrels from an ecosystem, and the effects ripple outward in complex ways. Our relationship with squirrels offers lessons in coexistence. In many places, humans and squirrels share spaces successfully, with minimal conflict. This coexistence requires understanding, tolerance, and sometimes compromise from humans. It also demonstrates that we can make room for wildlife in our modified landscapes if we choose to do so. The future of squirrels is, to a large extent, in human hands. We're shaping the world through climate change, habitat modification, and countless other activities. Whether squirrels thrive or struggle will depend on decisions we make about land use, conservation, and how we value biodiversity. This responsibility should inspire thoughtful stewardship. The mysteries that remain about squirrels should humble us. Despite centuries of observation and decades of scientific study, much about squirrel lives remains unknown. Every answered question reveals new questions. The inner experience of being a squirrel, the full richness of their sensory world, the complexities of their social relationships, all contain depths we're only beginning to explore. The diversity of squirrel species across the world showcases the creative power of evolution. From tiny pygmy squirrels to giant Indian squirrels, from gliding flying squirrels to burrowing ground squirrels, each species represents a unique solution to the challenges of survival. This diversity is precious, worth protecting for its own sake and for what it teaches us about life's possibilities. As you drift off to sleep, perhaps you'll dream of squirrels, bounding through trees, caching nuts for winter, raising their young in leafy drays, surviving through countless challenges. These small mammals, sharing our world, living their complex lives largely unseen, deserve our appreciation, our curiosity, and our care. They have been here for millions of years, adapting and persisting. May they continue for millions more, reminding future generations of the beauty and resilience of wild creatures. Sleep well, knowing that while you rest, somewhere a squirrel is beginning its day, gathering food, evading danger, and living out the ancient patterns that connect all life on Earth.